Hello there, and welcome to the Dreamy Ocean Channel. Perhaps your day has been a long voyage filled with currents and demands, leaving you feeling adrift. Now, as the light softens and the world outside begins to hush, allow yourself to settle deeply into this moment. Gently release the tension you might be holding in your shoulders, letting them drop away from your ears. Unclench your jaw, allowing a soft space between your teeth. Take a slow, deep breath, feeling your chest rise and fall with a peaceful rhythm, letting the noise of the day soften into a distant echo. The ocean, that vast, shimmering expanse, holds not only profound beauty, but also an ancient, indifferent power, a silent lexicon of challenges far beyond the familiar. It is a realm of breathtaking wonder, yet one where survival is a constant, elemental negotiation. Let us now, with gentle curiosity, allow our thoughts to drift upon its surface and ponder the deeper currents beneath. An introduction to ocean's scale and power. From a distant, silent vantage point in the cosmos, our world reveals itself as a shimmering sapphire jewel, a vibrant blue marble suspended in the infinite, inky blackness. This breathtaking hue is a testament to the ocean's dominion, an ever-present fluid expanse that cloaks nearly 3/4 of our planet's surface. It is a singular, colossal body of water, interconnected and ceaseless, where the Atlantic whispers into the Pacific and the Indian Ocean merges seamlessly into the Southern Sea, all breathing as one magnificent, unified entity. Imagine for a moment standing at the edge of this immense liquid realm, the horizon stretching out before you, an unbroken line where the vastness of the water meets the boundless sky. There is no discernible end, no physical barrier, only the continuous curve of the earth creating an illusion of infinite reach. This sheer, overwhelming scale is the ocean's most fundamental characteristic, a silent declaration of its power. It is a world unto itself, a living, breathing entity far larger and more complex than any landmass holding within its depths, secrets and forces that dwarf human comprehension. Beneath that shimmering surface lies an even more profound revelation, the ocean's immense volume. It is not merely a thin film spread across the globe, but a colossal reservoir containing approximately 1.3 billion cubic kilometers of water. To truly grasp this immense quantity, consider that if all the continents were to vanish, the Earth would be submerged beneath a uniform ocean nearly 3 kilometers deep. This colossal mass of water is in constant slow motion, a dynamic system of currents, upwellings and downwellings, moving with an inertia that is almost incomprehensible, a slow, patient titan that shapes our world with every passing moment. The average depth of this global ocean hovers around 3,700 meters a distance that already plunges us into perpetual twilight and then into utter darkness. Yet this average barely hints at the true abyssal depths. In specific, awe-inspiring locations, the ocean floor plummets into chasms so profound they make the highest mountains seem like mere ripples. The Mariana Trench, for instance, in the western Pacific Ocean, descends to a staggering 11,000 meters. To journey to its floor would be to travel a vertical distance greater than the height of Mount Everest. Picture a column of water 11 kilometers high, pressing down with an unimaginable force, a silent, crushing weight that transforms familiar concepts of space and time. Down in these sunless realms, the very structure of our reality shifts. The light from the sun, which penetrates only the uppermost layers, vanishes entirely, leaving a world bathed in eternal night. The temperature hovers just above freezing, a stark, unyielding cold that permeates everything. And most profoundly, the pressure becomes an omnipresent, suffocating embrace. At the deepest points, the pressure can exceed 1,000 times that at the surface, an equivalent of having 50 jumbo jets stacked upon a single human body. This is not a malicious force, but simply the unyielding consequence of gravity acting upon an immense volume of water, a fundamental physical reality of the deep ocean. It is an environment so alien, so extreme that it remains largely unexplored, a vast, indifferent cradle holding its secrets in an iron grip. The ocean's power is also profoundly evident in its ceaseless rhythmic movements, orchestrated by forces far beyond our terrestrial understanding. The tides, those majestic risings and fallings of the water along our coastlines, are a direct consequence of the gravitational pull exerted by the moon, and to a lesser extent, the sun. Imagine the moon, a distant celestial body reaching out with an invisible hand, gently yet powerfully tugging at the vast liquid body of our planet. Twice each day, in most locations, the ocean responds to this cosmic dance, inhaling and exhaling with a slow, deliberate cadence. This rhythmic surge and retreat of trillions of tons of water represents an astronomical transfer of kinetic energy, a silent testament to the interconnectedness of our planet with the wider solar system. The sheer volume of water moved in a single tidal cycle is staggering, a testament to the ocean's capacity for immense, sustained motion reshaping shorelines with patient geological precision over millennia. Beyond the gravitational ballet, the ocean is a realm of perpetual currents, vast liquid rivers flowing within its larger body. Surface currents driven primarily by global wind patterns form colossal gyres that circulate across entire ocean basins. The Gulf Stream, for instance, is a swift, warm current that transports an astounding 100 million cubic meters of water per second, a volume greater than all the rivers on Earth combined. These surface currents are not merely passive movements. They are dynamic forces that influence weather patterns, distribute marine life, and can effortlessly carry objects or even entire vessels across vast distances. To be caught within one of these powerful, relentless flows is to be swept into a journey dictated by the ocean's will, a testament to its inherent unyielding momentum. Even deeper beneath the wind-driven surface lies a slower, colder, but equally powerful system known as the thermohaline circulation, often referred to as the global conveyor belt. This immense deep ocean current is driven by differences in water temperature and salinity. Cold, dense, salty water sinks in polar regions, slowly creeping along the ocean floor towards the equator, eventually rising to the surface in warmer areas, completing a cycle that can take hundreds, even thousands of years. This deep circulation is a planetary engine distributing heat, oxygen, and nutrients across the entire globe, a silent subterranean river whose flow is so vast and slow that its true scale almost defies immediate comprehension. It is a fundamental component of Earth's climate system, a patient, powerful force that shapes the planet's heat balance with an indifferent geological efficiency. The ocean's thermal properties further underscore its immense power. Water possesses an extraordinarily high heat capacity, meaning it can absorb and store vast amounts of thermal energy without experiencing significant temperature changes itself. This makes the global ocean the Earth's primary heat, sink, and regulator. It patiently absorbs solar radiation, particularly in tropical regions, and slowly releases it back into the atmosphere, or distributes it through its currents to higher latitudes. This colossal thermal inertia moderates our planet's climate, preventing extreme temperature fluctuations that would render much of the land uninhabitable. The ocean holds within its depths enough thermal energy to influence global weather patterns for decades, even centuries, a vast, slow-burning furnace that dictates the very breath of our atmosphere. The subtle shifts in its temperature, often imperceptible to human senses, can trigger profound changes in global climate, demonstrating its immense patient power to shape the very conditions of life on Earth. Chemically, the ocean is a complex saline solution, a vast chemical reactor where countless elements and compounds are dissolved and interact. On average, seawater contains about 3.5% dissolved salts, primarily sodium chloride, but also magnesium, sulfate, calcium, and potassium, among many others. This salinity is not just a taste, it influences water density, freezing point, and the very chemistry of life within its waters. Over geological timescales, the ocean has patiently eroded continents, carrying dissolved minerals to its depths, contributing to the very composition of its waters. This constant chemical interaction, though slow, is incredibly powerful, capable of dissolving rock-shaping submarine landscapes and influencing the availability of nutrients for marine organisms. It is a subtle yet pervasive force, a silent chemical solvent that works tirelessly, shaping the very fabric of the planet. In essence, the ocean is not merely a body of water. It is a colossal dynamic system, a physical force of nature whose scale and power are truly humbling. It is a vast, indifferent cradle that has nurtured life for billions of years, providing the very conditions for its existence. Yet, in its profound indifference, in its sheer scale, its crushing depths, its relentless currents, and its unyielding chemical and thermal properties, it presents an environment of formidable challenge. It is not actively hostile, but simply is, a realm governed by physical laws so immense that human fragility can often find itself overwhelmed. As we gently explore the ocean's specific challenges in the chapters to come, remember this fundamental truth that the ocean's power is not a malicious intent, but simply the colossal, indifferent reality of its being a majestic force that demands our profound respect and quiet contemplation. Let this understanding of its sheer, unyielding magnitude settle gently within your thoughts as we prepare to drift deeper into its mysteries, waves, currents, and the pull of tides. The ocean's surface, that vast shimmering membrane where the liquid realm meets the open air, often presents itself as a picture of serene beauty, a canvas of blues and greens beneath the endless sky. Yet beneath this tranquil veneer, or amidst its more tempestuous moods, lies a dynamic, ceaseless interplay of forces, the rhythmic rise and fall of waves, the patient, persistent sweep of currents, and the majestic gravitational breathing of the tides. Each of these phenomena, born of distant winds or celestial pulls, orchestrates a deceptive dance inviting us closer, while holding the potential for an indifferent, overwhelming embrace. Consider first the genesis of a wave. It begins as a mere ripple, a subtle tremor upon the water born from the gentle caress of a passing breeze. As this breeze transforms into a steady wind, its energy, a kinetic breath, transfers itself to the water's surface through a continuous friction. Picture countless tiny hands, invisible and relentless, pushing against the liquid skin, slowly building momentum. Given sufficient time for this interaction, known as duration, and an uninterrupted expanse of water over which the wind can blow, called fetch, these ripples grow. They coalesce, drawing energy from the wind and from each other, transforming into larger, more defined undulations. These wind-generated waves are not a simple forward movement of water itself, but rather a propagation of energy. Imagine a gentle swell lifting a floating leaf, then lowering it only to lift it again as the next wave crest arrives. the leaf essentially moves in a circular path, returning almost to its original position, demonstrating that the water largely stays put while the wave's energy travels onward. These open ocean waves, or swells, can journey thousands of kilometers across entire ocean basins, carrying the distant memory of a storm's fury to a faraway, unsuspecting shore. They travel with a stately, predictable rhythm, their smooth, rounded crests and troughs a testament to their long, unimpeded journey. However, as these waves approach the shallower waters of a coastline, their character begins to profoundly transform. The invisible hand of the seabed rises to meet the traveling energy. The wave's orbital motion, once unhindered in deep water, now encounters the friction of the rising bottom. This interaction causes the wave to slow down, its wavelength to shorten, and its height to dramatically increase, as if compressing its stored energy into a taller, steeper form. The crest, moving faster than the base, eventually becomes unstable, leaning forward until it can no longer support itself. With a majestic, often thunderous roar, it topples forward, breaking into a cascade of foam and aerated water, the familiar, powerful spectacle of a breaking wave. This surf zone, where waves continually break, is a region of immense chaotic energy. The sheer force of these breaking waves can be astonishing. A moderately sized wave can exert pressures equivalent to thousands of kilograms per square meter, capable of lifting and tossing entire vessels or relentlessly eroding solid rock over time. For a human caught within this churning maelstrom, the force is immediate and overwhelming. The water becomes a battering ram, pushing, pulling, and rolling, making it almost impossible to maintain footing or direction. The turbulent, aerated water also reduces buoyancy, making it harder to stay afloat, while the constant thrashing can lead to disorientation, exhaustion, and the involuntary inhalation of water, a silent, insidious threat. Beyond the direct impact of breaking waves, the surf zone holds another, often more insidious danger: the undertow. After a wave breaks and rushes up the beach, the vast volume of water must return to the sea. This receding water forms a strong, bottom-hugging current that flows directly back out beneath the incoming waves. While often less powerful than a rip current, the undertow can be strong enough to pull a swimmer off their feet and drag them further into deeper water, contributing to fatigue and panic, especially for those less experienced in the ocean's embrace. It is a subtle, persistent pull, an unseen hand, drawing one away from the perceived safety of the shore. Even more perilous are the infamous rip currents, often mistaken for undertows. A rip current is a narrow, powerful channel of water flowing rapidly away from the shore, often appearing deceptively calm, where the waves seem to be breaking less frequently. These currents form when large volumes of water pushed onto the beach by incoming waves find a path of least resistance to flow back out to sea. This path might be a gap in a sandbar, a slight depression in the seabed, or near a jetty or pier. A rip current can be incredibly swift, reaching speeds of up to 2.5 meters per second, faster than an Olympic swimmer. Imagine floating peacefully near the shore, perhaps enjoying the gentle sway of the water, when suddenly, with no visible warning, you feel an accelerating pull. The familiar sand beneath your feet vanishes, and the shore begins to recede with alarming speed. Panic can set in quickly as the realization dawns that you are being carried relentlessly seaward away from the safety of the beach. The instinct to fight against the current to swim directly back to shore is a natural but often fatal response. Such an effort quickly leads to exhaustion, as the current is simply too strong to overcome. The true danger of a rip current lies not in its ability to pull you under, but in its relentless ability to carry you away from shore, and induce debilitating fatigue. The ocean's currents extend far beyond the immediate coastline, orchestrating immense global movements of water that shape continents and climates. These vast liquid rivers, driven primarily by persistent wind patterns, Earth's rotation at the Coriolis effect, and differences in water density, form intricate, interconnected systems across the planet. The great ocean gyres, for instance, are colossal circular current systems that dominate the central regions of each major ocean basin. The North Atlantic gyre, encompassing the mighty Gulf Stream, is a mesmerizing example. The Gulf Stream itself is an astonishing phenomenon, a warm, swift current originating in the Gulf of Mexico and flowing northward along the eastern coast of North America, eventually crossing the Atlantic towards Europe. This massive current transports an unimaginable volume of water, estimated at 100 million cubic meters per second, a flow rate greater than all the rivers on Earth combined. Its warmth, carried from tropical latitudes, moderates the climate of Western Europe, making regions like Ireland and the United Kingdom far milder than their high latitudes would otherwise suggest. To be caught in the main flow of such a current, particularly in the open ocean, means surrendering entirely to its direction being carried along its immense, unwavering path. For a lost vessel or an adrift person, it dictates their fate with an indifferent, unyielding power, carrying them thousands of kilometers from their original position, often into zones of extreme temperature or away from shipping lanes, reducing the chances of rescue to a whisper. Even in seemingly calmer waters, the pull of the tides, those majestic rhythmic risings and fallings of the sea, generate powerful currents. While the gravitational dance of the moon and sun dictates the vertical movement of water, the horizontal flow of water in response to this gravitational force creates tidal currents. As the tide comes in, water surges into bays, estuaries, and narrow channels, creating what is known as a flood current. When the tide recedes, the water flows back out to sea, forming an ebb current. In constricted areas such as inlets, straits, or river mouths, these tidal currents can become incredibly swift and turbulent. Imagine a narrow passage between two land masses where billions of tons of water are forced to flow through a confined space. The resulting current can create powerful whirlpools, standing waves, and violent eddies, transforming a placid channel into a dangerous, churning maelstrom. For a small boat or a swimmer, these strong tidal currents can be utterly overwhelming, dragging them against rocks, pulling them out to sea, or simply exhausting them in their futile struggle to maintain position. The speed and direction of these currents change predictably with the tidal cycle, yet their sheer force remains a constant, formidable challenge, particularly during spring tides when the gravitational pulls of the moon and sun align, creating the greatest tidal ranges, and thus the strongest currents. The dynamic interplay of waves, currents, and tides at the ocean's surface creates an environment of constant, often unpredictable movement. A seemingly calm day can quickly turn treacherous with the arrival of an unexpected swell or the subtle shift of a coastal current. The beauty of the breaking wave, the relentless sweep of a gyre, the rhythmic ebb and flow of the tide. Each is a manifestation of the ocean's immense energy, a constant reminder of its indifferent power. These surface phenomena, while part of the Earth's natural breathing, demand a profound respect, for they operate on scales and with forces that dwarf human capabilities. As these thoughts gently drift through your mind, perhaps you can visualize the vast, ever-moving surface of the global ocean, a colossal, fluid engine ceaselessly at work. The waves that roll towards distant shores, the currents that traverse entire basins, and the tides that rhythmically embrace and release the land are all expressions of a power that predates humanity and will continue long after. Let the image of this dynamic, beautiful, yet profoundly indifferent surface settle like a soft blanket, carrying you further into the gentle understanding of its deep, hidden forces. Unyielding pressure in the deep ocean. As the gentle sway of the surface currents and the rhythmic breath of the tides begin to recede, from our awareness, we turn our gaze and our thoughts downward. Beneath that shimmering, dynamic membrane of water lies a realm governed by a force far more ancient and unyielding pressure. With every meter of descent into the vast liquid embrace of the ocean, this invisible, omnipresent weight begins to assert itself, building steadily, silently, relentlessly. At the familiar surface of our world, the air above us exerts its own subtle pressure, a constant, gentle push of approximately 1 atmosphere or about 101 kilopascals. This is the weight of the entire column of air stretching from the ground to the edge of space, pressing down upon every square centimeter of our bodies, a force we are utterly accustomed to barely perceiving its presence. However, when we transition from air to water, the density changes profoundly. Water is approximately 800 times denser than air, and it is this immense density that translates into a rapidly escalating pressure with every downward plunge. For every 10 meters one descends into the ocean's depths, the pressure increases by another full atmosphere. This means that at just 10 meters below the surface, the total pressure is already 2 atmospheres, the weight of the water column now equaling the entire atmosphere above it. At 20 meters, it is 3 atmospheres, and so on an arithmetic progression that quickly leads to staggering values. Imagine for a moment the sensation of this accumulating weight. It is not a sudden blow, but a gradual, pervasive squeeze, as if an invisible hand is slowly but firmly pressing in from every direction, seeking out every void, every softness, every space. For a human body, especially one unprepared for the ocean's depths, the initial effects of this mounting pressure are felt most acutely in the air-filled cavities. The delicate structures of the ears, sinuses, and lungs designed for the airy environment of the surface become vulnerable. As one descends, the air within these spaces compresses, shrinking in volume. If this compression is not equalized, if air cannot freely move into these spaces to match the external pressure, the surrounding tissues begin to bulge inward, straining blood vessels and nerves. This excruciating pain, known as barotrauma, is the ocean's first sharp reminder of its physical laws. The eardrum's thin and sensitive membranes can rupture with a sudden, deafening pop, leading to disorientation and severe agony. Sinuses can fill with blood, and even teeth with untreated cavities can ache with an unbearable internal pressure. Beyond these immediate painful warnings, the deep ocean presents more insidious dangers to those who venture too far, too fast, or for too long. For divers breathing compressed air, the increased pressure forces gases, particularly nitrogen, to dissolve into the bloodstream and tissues at higher concentrations than they would at the surface. This is a silent, invisible process without immediate sensation. However, if a diver ascends too quickly, the external pressure rapidly decreases and the dissolved nitrogen can no longer remain in solution. It begins to bubble out of the blood and tissues, much like the fizzing gas released when a carbonated drink bottle is opened. These nitrogen bubbles forming within joints, muscles, the spinal cord, and even the brain are the cause of decompression sickness, commonly known as the bends. The symptoms of the bends are agonizing and varied depending on where these insidious bubbles form. They can manifest as excruciating pain in the joints, a deep, persistent ache that might feel like a slow, tearing sensation. Bubbles in the spinal cord can lead to paralysis, a sudden, terrifying loss of control over one's limbs. In the lungs, they can cause a dry, hacking cough and severe breathing difficulties as if struggling to draw air through a constricted passage. If they reach the brain, the consequences can be catastrophic seizures, confusion, disorientation, or even unconsciousness. The treatment involves immediate recompression in a specialized chamber, slowly reducing the pressure to redissolve the bubbles, then gradually decompressing the diver over many hours or even days. It is a stark illustration of the ocean's unforgiving nature, where a momentary lapse in judgment or a rapid ascent can unleash a silent internal catastrophe. Another profound effect of increased pressure on divers breathing compressed air is nitrogen narcosis, often referred to as rapture of the deep. As nitrogen dissolves into the nervous system at greater depths, typically beyond 30 meters, it begins to act as an anesthetic similar to the effects of alcohol intoxication. Thoughts become muddled, judgment is impaired, and a sense of euphoria or anxiety can take hold. A diver might feel a false sense of invincibility or conversely be gripped by irrational fear. Simple tasks become difficult, and critical decisions such as monitoring air supply or depth become prone to error. The ocean, with its quiet, crushing embrace, can subtly alter the very fabric of one's perception, leading to dangerous choices in an already perilous environment. Furthermore, at extreme depths, even oxygen, the very gas essential for life, becomes toxic under high partial pressures. Oxygen toxicity can manifest in a variety of ways, from visual disturbances and twitching to severe convulsions, which underwater can be lethal, leading to the loss of a regulator and subsequent drowning. It is a cruel paradox of the deep. The very element that sustains us at the surface becomes a poison when forced into our systems under the ocean's immense squeeze. For anything not designed to equalize internal and external pressure, the deep ocean's embrace is one of pure, unyielding destruction. Imagine a simple plastic cup light and airy at the surface. As it descends, the pressure compresses the air within it until the external water pressure becomes so overwhelming that the cup crumples inward, imploding with a silent, instantaneous force reduced to a fraction of its original size. Now extend this image to larger, more complex structures. An unsupported human body or any air-filled vessel not designed to withstand the crushing forces would suffer a similar catastrophic fate. The air within would compress to nothing, and the body's fragile structure would be flattened, collapsed by the sheer indifferent weight of the water. This is the constant existential threat faced by submarines and deep-sea submersibles. Their very existence in the abyssal plains is a testament to extraordinary feats of engineering. Their hulls are constructed from incredibly strong, thick materials, like high-strength steel or titanium, meticulously designed to form a perfect sphere or cylinder, the most efficient shapes for distributing external pressure evenly. Every weld, every seam, every penetrator for cables or sensors must be engineered to withstand forces equivalent to thousands of tons, pressing down on every square meter. Imagine being inside such a submersible, slowly descending into the perpetual darkness. The silence of the deep is punctuated only by the occasional creak and groan of the hull, the subtle, almost imperceptible sounds of the metal contracting and resisting the unimaginable external squeeze. These sounds are not merely noise, they are the audible manifestation of the constant titanic struggle between the vessel's integrity and the ocean's unyielding embrace. A tiny flaw, a microscopic crack, a momentary lapse in material strength could lead to a catastrophic instantaneous implosion where the vessel is crushed into a compact mass in a fraction of a second, leaving no survivors, no trace, only the silent, indifferent water closing in. The energy released by such an event is immense, a testament to the raw power of the ocean's depth. Yet life in its infinite adaptability has found a way to not only survive, but to thrive in these crushing conditions. The creatures of the deep abyss, far removed from the sunlit surface, have evolved remarkable adaptations to defy the overwhelming pressure. Many deep-sea fish, for instance, lack gas-filled swim bladders which would simply collapse under the immense pressure. Instead, they rely on neutral buoyancy achieved through low-density oils or gelatinous bodies. Their tissues and cells are designed to function under extreme compression. Their proteins and enzymes are specialized, folded in ways that maintain their structure and activity at pressures that would denature and destroy their surface counterparts. They are often soft-bodied with flexible skeletons, allowing their bodies to yield rather than resist the external force, becoming one with the pressure rather than fighting against it. These creatures, sometimes called piezophiles or pressure-loving organisms, have fundamentally different physiologies. Their cells contain specialized organic osmolytes that counteract the pressure's disruptive effects on biochemical processes. They are living proof that the ocean's crushing embrace, while lethal to surface life, is merely a fundamental condition for their existence, a natural state to which they are perfectly attuned. They swim and hunt in a world where every cubic centimeter of water exerts an immense force, a world where the concept of up and down is defined not by light, but by the gradual, unwavering increase of an invisible burden. At the very deepest known points of our planet, in the abyssal trenches, like the Mariana Trench's Challenger Deep, the pressure reaches its absolute zenith. Here, at depths exceeding 11,000 meters, the water presses down with a force of more than 1,100 atmospheres. To visualize this, imagine 100 fully loaded jumbo jets stacked upon a single square centimeter of surface. Or picture the weight of an entire herd of elephants balanced on your thumb. This is not a hypothetical scenario. It is the constant crushing reality for any object or organism that descends to these profound depths. It is an environment so utterly alien, so profoundly hostile to anything not specifically adapted, that it remains one of the least explored frontiers on Earth, a silent, dark realm where the very laws of physics seem to amplify their power. The unyielding pressure of the deep ocean is not a malevolent entity, but simply a fundamental consequence of gravity acting upon an immense dense fluid. It is an ancient, indifferent force that has shaped the very geology of the ocean floor, sculpted the evolution of its unique inhabitants, and continues to dictate the boundaries of human exploration. It is a silent, pervasive presence, a constant reminder that beneath the welcoming shimmer of the surface lies a world where the very act of existing is a testament to resilience or an immediate surrender to the ocean's colossal, crushing embrace. Let this profound understanding of pressure, its silent power, and its shaping influence settle gently within your mind as we continue our slow journey into the ocean's formidable depths. Temperature extremes of the water column. Beyond the unyielding squeeze of pressure as we continue our slow descent into the ocean's vastness, another formidable yet often invisible force begins to assert its dominance: temperature. From the sun-warmed caress of the surface to the abyssal chill of the deepest trenches, the ocean presents an astonishing spectrum of thermal conditions, each capable of profoundly impacting life and dictating the very boundaries of survival. It is a silent thermometer measuring the immense energy flows that sculpt our planet, and for the unprepared it can offer a touch that either burns with a sudden shock or numbs with a slow, insidious cold. At the very surface in tropical and subtropical regions, the ocean acts as a colossal solar panel, absorbing the sun's radiant energy. Here, the uppermost layers of water can bask in temperatures soaring to 30 degrees Celsius or even higher, particularly in shallow enclosed bays or during intense summer months. Imagine slipping into this warm, inviting water, feeling the sun's lingering heat permeate your skin, a comforting embrace that speaks of leisure and life. This warmth is not merely superficial, it fuels vast ecosystems from vibrant coral reefs, teeming with life, to extensive mangrove forests along coastlines. It drives evaporation, feeding the atmospheric engine that creates rainfall and weather patterns across the globe. For marine life adapted to these balmy conditions, a sudden drop in temperature can be as lethal as a harsh frost to a tropical plant. However, even within these seemingly benign warm waters, the ocean can present its own thermal challenges. Rapid changes in water temperature, perhaps due to upwelling of colder deep water, or the shifting of currents can shock marine organisms, leading to stress disease or even mass mortality events. For humans, prolonged exposure to excessively warm water, particularly in stagnant conditions, can lead to heat exhaustion or heat stroke, especially if combined with dehydration. The body struggles to dissipate its own heat, and the external warmth of the water can become an overwhelming burden, blurring the line between comfort and danger. As one journeys from the equator towards the poles, the surface waters steadily cool, reflecting the diminishing angle of the sun's rays. In temperate zones, the ocean experiences seasonal shifts, warming in summer and chilling in winter, creating dynamic environments that support a diverse array of migratory species. But it is in the polar regions around the Arctic and Antarctic where the ocean reveals its most extreme cold. Here, vast expanses of water remain at temperatures hovering around 0 degrees Celsius or even slightly below, due to the dissolved salts that lower the freezing point of seawater. Ice in its myriad forms, from colossal icebergs carved from glaciers to vast shifting sheets of sea ice, dominates the landscape, a stark testament to the ocean's icy grip. For a human body immersed in these frigid waters, the effects are swift and brutal. The human core body temperature, normally around 37 degrees Celsius, is meticulously maintained by complex physiological processes. When plunged into water near freezing, the body immediately begins to lose heat at an astonishing rate, 25 times faster than in air of the same temperature. This rapid heat loss triggers an involuntary gasp reflex, a sudden uncontrolled inhalation that can easily lead to drowning if the head is submerged. This initial cold shock can also induce hyperventilation, dizziness, and a rapid uncontrolled increase in heart rate and blood pressure, potentially leading to cardiac arrest in vulnerable individuals. Beyond the initial shock, prolonged immersion in cold water leads to hypothermia, a progressive cooling of the body's core. Within minutes, fine motor skills begin to degrade, making it incredibly difficult to perform simple tasks, like grasping a lifeline or fastening a life vest. Muscles stiffen and ache coordination falters, and a profound sense of numbness spreads throughout the limbs. The ability to swim or even tread water quickly diminishes as the body conserves its remaining energy for vital organs, sacrificing peripheral functions. As the core temperature continues to drop, mental faculties become impaired. Confusion sets in, judgment becomes clouded, and a dangerous apathy can creep over the mind, making rescue efforts more challenging. Speech becomes slurred and shivering. The body's desperate attempt to generate heat eventually ceases as the energy reserves are depleted. At a core temperature of around 28 degrees Celsius, unconsciousness sets in, followed by cardiac arrest. The silent chill of the ocean, far from being a dramatic, instantaneous threat, is a patient, insidious killer slowly robbing the body of its warmth, its strength, and ultimately its life, leaving behind only the profound indifference of the cold water. As we descend deeper into the ocean's vast column, an even more profound and pervasive cold takes hold. Below the sunlit surface layer, typically between 100 and 200 meters, lies a region known as the thermocline. Here, the temperature drops rapidly with increasing depth, a dramatic transition from the warmer surface waters to the perpetually cold abyss. This thermocline acts as a thermal barrier separating the two distinct layers and influencing the distribution of marine life and the mixing of ocean waters. Below the thermocline, in the vast expanse of the deep ocean, from hundreds of meters down to the deepest trenches, the temperature remains remarkably constant and relentlessly cold. Here, far removed from the sun's warming rays, the water hovers just above freezing, typically between 0 and 4 degrees Celsius. This abyssal cold is eternal, unchanging, a testament to the ocean's immense volume and its slow, deep circulation patterns. It is a world of perpetual twilight and then utter darkness, where life has adapted to function at temperatures that would instantly shut down the biochemical processes of most surface organisms. Yet even in these realms of profound cold, the ocean can present pockets of intense, searing heat. These are the hydrothermal vents often found along mid-ocean ridges and volcanic hotspots on the seafloor. Here, superheated water, infused with dissolved minerals from the Earth's crust, spews forth from chimney-like structures, creating plumes of black or white smoke. The temperature of this vent fluid can reach astonishing highs, sometimes exceeding 400 degrees Celsius, far hotter than boiling water at the surface. This is because the immense pressure at these depths prevents the water from boiling, allowing it to remain in a superheated liquid state. Imagine approaching one of these vents in a deep-sea submersible. The surrounding abyssal water is just a few degrees above, freezing a vast, dark, cold expanse. Then emerging from the seafloor are these towering chimneys glowing faintly with the heat, releasing plumes of scalding, chemically rich fluid that shimmer and distort the water around them. For any organism not specifically adapted to this extreme thermal gradient, contact with the vent fluid would be instantaneous incineration, a sudden violent end in the midst of the freezing darkness. The contrast is stark, almost unimaginable, a world of silent, pervasive cold, punctuated by volcanic bursts of liquid fire. Remarkably, these hydrothermal vents, despite their extreme temperatures and toxic chemical composition, support unique and thriving ecosystems. Specialized microbes known as chemosynthetic bacteria form the base of these food webs, deriving energy not from sunlight, but from the chemical reactions of the vent fluids. These bacteria, in turn, sustain an astonishing array of bizarre and wonderful creatures: giant tube worms with blood-red plumes, enormous white crabs, strange mollusks, and unique shrimp, all living their entire lives in the perpetual darkness and extreme thermal gradients around these underwater volcanoes. Their enzymes and proteins are designed to function at temperatures that would denature most other forms of life, a testament to the extraordinary adaptability that evolution can forge even in the most hostile environments. So from the sun-drenched warmth of the surface to the icy grip of the deep, and from the pervasive abyssal chill to the searing touch of hydrothermal vents, the ocean's thermal landscape is one of breathtaking extremes. It is a world where temperature as much as pressure defines the boundaries of existence. For humans, the cold of the surface waters poses an immediate, insidious threat, slowly stealing away life's warmth. And even in the deepest, darkest reaches where life adapts to the perpetual chill pockets of extreme heat, remind us of the Earth's inner fire, making the ocean a realm of both silent, relentless cold and sudden, burning touch. Let this understanding of the ocean's thermal extremes settle softly into your thoughts, a quiet contemplation of its vast, indifferent power, as we continue our gentle journey into its profound mysteries. Chemical threats, hypoxia, and the ocean's breath. As the profound embrace of crushing pressure and the stark contrasts of thermal extremes begin to recede, our journey now turns to an even more insidious, often invisible category of dangers that permeate the vast liquid world: the silent threats of chemical imbalance, the slow suffocation of oxygen depletion, and the subtle yet potent presence of hidden poisons. The ocean, in its immense capacity, is a global solvent capable of holding countless substances within its depths, some vital for life, others capable of stealing its very breath. At the heart of the ocean's ability to sustain the vibrant tapestry of marine life lies a fundamental, invisible element: dissolved oxygen. Just as we, on land, draw our breath from the air, the vast majority of creatures beneath the waves require oxygen suspended within the water to fuel their metabolic processes. This vital gas enters the ocean primarily through two majestic pathways. Firstly, at the surface, where the ceaseless dance of wind and waves creates a continuous exchange with the atmosphere. Imagine the gentle undulations of the sea, the soft white foam of a breaking wave, each tiny bubble a momentary breath of air dissolving into the liquid, enriching it with life-giving oxygen. Secondly, and equally profoundly microscopic marine plants, the phytoplankton floating in the sunlit upper layers, tirelessly perform photosynthesis. Like their terrestrial cousins, they absorb carbon dioxide and release oxygen, silently infusing the surrounding waters, with this essential gas providing the very foundation for marine respiration. The distribution of this vital dissolved oxygen is not uniform throughout the ocean's vastness. Colder waters, particularly in the polar regions, possess a greater capacity to hold dissolved gases, including oxygen. As these dense, cold, oxygen-rich waters sink and slowly creep along the abyssal plains, they carry a precious cargo of life-sustaining breath into the deepest, darkest realms. However, oxygen is constantly being consumed by the respiration of marine organisms and the decomposition of organic matter that drifts down from the surface. This delicate balance between supply and demand dictates the very habitability of vast swathes of the deep ocean. Yet this vital breath can be stolen silently and insidiously, leading to conditions of hypoxia, low oxygen, or even anoxia, the complete absence of oxygen. These dead zones are not merely barren patches of sand. They are regions where life as we know it struggles, sickens, and ultimately perishes. Some areas of the ocean naturally experience lower oxygen levels, forming what scientists call oxygen minimum zones, often due to sluggish circulation patterns and the extensive consumption of oxygen by decaying organic matter in deep, stratified waters. These are ancient natural features to which some specialized life forms have adapted. However, many contemporary dead zones are a direct consequence of human activity, a silent, pervasive poisoning of the ocean's breath. Picture a coastal landscape where fertile farmlands stretch towards the sea, or bustling cities release their treated or sometimes untreated effluents. Rain washes excess nutrients, primarily nitrogen and phosphorus from agricultural fertilizers, sewage, and industrial discharges, into rivers and streams which then patiently carry them seaward. As these nutrient-rich waters flow into coastal bays and estuaries, they act as a potent stimulant for the growth of microscopic marine algae, triggering what are known as algal blooms. These blooms, sometimes so dense they paint the surface water with vivid hues of green, red, or brown, are initially a burst of life. But like a fire consuming all its fuel, this explosion of growth is short-lived. When the vast populations of algae eventually die, their microscopic bodies sink towards the seafloor, forming a rain of organic detritus. Here, legions of bacteria begin their tireless work of decomposition, breaking down this organic matter. This decomposition is an aerobic process, meaning these bacteria voraciously consume dissolved oxygen from the surrounding water. As billions upon billions of bacteria feast, the oxygen levels in the bottom waters plummet sometimes to near zero. The effect on marine life is devastating. Imagine a fish swimming placidly, suddenly feeling the water thicken its gills, burning, unable to extract the vital oxygen it needs. It begins to gasp, to flee desperately, seeking more oxygenated waters. Crabs and lobsters crawl out of the suffocating sediments, attempting to escape the invisible poison. Sessile organisms like oysters and clams, trapped in the oxygen-depleted zones, simply suffocate their shells, becoming silent tombs. The once vibrant benthic community, the life on the seafloor, becomes a desolate landscape littered with the bodies of those unable to escape. The water itself can take on a murky, stagnant appearance sometimes, even emitting the faint, acrid scent of hydrogen sulfide, a gas produced by anaerobic bacteria thriving in the total absence of oxygen. These dead zones, expanding and contracting with the seasons and the influx of nutrients, are a stark reminder of the ocean's vulnerability to the subtle chemical shifts we impose upon it. Beyond the depletion of oxygen, the ocean is also a vast recipient of a multitude of chemical pollutants, many of which are invisible, odorless, and yet profoundly toxic. Among the most insidious are heavy metals, such as mercury, lead, and cadmium. These elements, naturally present in trace amounts, are introduced into the ocean in far greater concentrations through industrial processes, mining, and the burning of fossil fuels. Once in the marine environment, they do not simply disappear. Instead, they become incorporated into the food web through a process called bioaccumulation. Microscopic plankton absorb tiny quantities which are then consumed by small fish, which are in turn eaten by larger fish. At each step up the food chain, these heavy metals become more concentrated in the tissues of the organisms, a phenomenon known as biomagnification. Consider the journey of a single mercury atom released from a power plant stack. It drifts into the atmosphere, eventually settling upon the ocean's surface, slowly dissolving into the water. A tiny phytoplankton absorbs it. A small copepod grazes on the phytoplankton, accumulating a slightly higher dose. A sardine devours many copepods, and its mercury burden increases further. A tuna, a majestic apex predator, consumes hundreds of sardines over its lifetime, concentrating the mercury to levels that can be hundreds of thousands of times higher than in the surrounding seawater. For humans, consuming these contaminated seafoods, particularly large, long-lived predatory fish, the consequences can be severe: neurological damage, developmental issues in children, and various organ system failures. The ocean, in its silent processing of these pollutants, becomes a pathway for these invisible poisons to enter our own bodies. Equally pervasive are persistent organic pollutants, or POPs. These are synthetic chemicals such as polychlorinated biphenyls, PCBs, DDT, pesticides, and dioxins produced by human industry. They are characterized by their remarkable stability, resisting degradation in the environment for decades, even centuries. They are also lipophilic, meaning they readily dissolve in fats and oils, allowing them to accumulate efficiently in the fatty tissues of marine organisms. Like heavy metals, POPs undergo biomagnification, reaching alarmingly high concentrations in apex predators like marine mammals, whales, dolphins, seals, and large seabirds. These creatures at the top of their food chains can carry chemical burdens that impact their reproductive success, suppress their immune systems, and disrupt their endocrine functions, slowly weakening populations from within. The ocean, with its vast currents, acts as a global transporter, carrying these invisible chemical signatures from industrial centers to the most remote polar regions, polluting ecosystems far from their source. Even the ubiquitous presence of plastic, a seemingly inert material, poses a chemical threat. As plastic debris breaks down into ever smaller fragments, microplastics and nanoplastics, it not only presents a physical danger to marine life that ingests it, but it also leaches chemicals into the water and into the tissues of organisms. Plastics are manufactured with various additives such as phthalates, bisphenol A, BPA, and flame retardants, many of which are known endocrine disruptors, mimicking or interfering with hormones in marine animals. Furthermore, microplastics act as tiny sponges, absorbing other pollutants like POPs and heavy metals from the surrounding seawater, then carrying these concentrated toxins into the digestive tracts of the animals that consume them. The ocean's waters become a slow, patient brew of synthetic chemicals, subtly altering the fundamental biology of its inhabitants. And then there are the acute, dramatic chemical events such as oil spills. While the physical coating of crude oil on marine life is devastating, the chemical toxicity of its components is equally lethal. Oil is a complex mixture of hydrocarbons, many of which are acutely toxic. Volatile organic compounds evaporate quickly, creating toxic fumes in the immediate aftermath, while heavier fractions persist in the water column and sediments for years, even decades. These hydrocarbons can cause internal organ damage, suppress immune systems, and impair reproduction in fish, birds, and marine mammals. The pungent, choking odor of crude oil, the sticky black sheen spreading across the water, is a visible manifestation of a profound chemical assault, a sudden, overwhelming poison poured directly into the ocean's breath. Finally, a more subtle yet globally pervasive chemical shift is occurring in the ocean, a phenomenon known as ocean acidification. As humanity releases vast quantities of carbon dioxide into the atmosphere, a significant portion of this gas is absorbed by the ocean. When carbon dioxide dissolves in seawater, it reacts to form carbonic acid, which then releases hydrogen ions, subtly lowering the pH of the ocean. This process is not a sudden, dramatic poisoning, but a slow, relentless chemical alteration of the ocean's very chemistry, akin to a gradual erosion of its fundamental balance. The most profound impact of this acidification is on calcifying organisms. Creatures that build shells or skeletons out of calcium carbonate, such as corals, oysters, mussels, sea urchins, and microscopic plankton like pteropods and foraminifera, find it increasingly difficult to extract the necessary carbonate ions from the more acidic water. Their shells become thinner, weaker, and more prone to dissolution, particularly in colder, deeper waters, where the effects are amplified. Imagine a delicate shell, the very protective home of a tiny snail, slowly dissolving, becoming fragile and brittle, unable to withstand the pressures of the environment. This silent chemical shift threatens the very foundation of marine food webs, as these calcifying organisms form critical links in the oceanic ecosystem. It is a slow, pervasive chemical stress, altering the ocean's breath in a way that threatens to reshape life itself, a testament to the profound, long-reaching consequences of our atmospheric emissions. From the quiet suffocation of dead zones to the insidious biomagnification of heavy metals, from the persistent, subtle assault of POPs and microplastics to the sudden chemical shock of oil spills and the slow, pervasive erosion of ocean acidification, the ocean faces a myriad of invisible chemical threats. These are not the dramatic, visible forces of waves or crushing pressure, but rather a silent, pervasive poisoning. A slow erosion of the ocean's capacity to sustain life. They remind us that the ocean's breath is a delicate balance easily disrupted, and that its immense volume, while capable of absorbing much, has its profound limits. As these thoughts of invisible dangers gently settle, let us prepare to explore yet more of the ocean's formidable challenges. To tsunamis, submarine landslides, and volcanic vents. As our thoughts drift deeper beyond the pervasive, invisible chemical shifts that permeate the ocean's breath, we now turn our attention to the very foundation of this liquid world, the Earth's restless floor. Far beneath the sunlit surface, hidden by kilometers of water, lies a dynamic, often violent landscape of mountains, valleys, plains, and chasms, where the slow, patient forces of geology constantly reshape our planet. It is from this unseen realm that some of the ocean's most profound and catastrophic dangers can silently emerge, unleashing forces that dwarf human endeavors and remind us of the immense, indifferent power of our living Earth. Foremost among these profound geological threats are tsunamis, those majestic and terrifying waves of destruction that bear little resemblance to the familiar wind-driven swells of the surface. The word tsunami itself, originating from Japanese, translates to harbor wave, a poignant acknowledgement of their devastating arrival in coastal communities. These colossal waves are almost always born from sudden, massive displacements of the seafloor, primarily triggered by powerful underwater earthquakes. Imagine two colossal tectonic plates grinding against each other deep beneath the ocean, locked in a slow geological embrace for centuries. The pressure builds immense and relentless, until with a sudden violent lurch, one plate slips catastrophically beneath the other or slides horizontally. This abrupt movement of the ocean floor acts like a colossal paddle, vertically displacing an entire column of water from the seabed all the way to the surface. Unlike wind waves, which only disturb the uppermost layers of the ocean, a tsunami involves the movement of the entire water column, encompassing its immense depth. In the vast open ocean where the water is kilometers deep, a tsunami is a deceptive phenomenon. It travels at astonishing speeds comparable to a jet airliner, often 500 to 900 kilometers per hour. Yet paradoxically, its height in deep water is barely perceptible, sometimes no more than a gentle, long-period swell of perhaps only a few tens of centimeters. A ship in the open ocean might pass over a tsunami entirely unaware, experiencing only a slight prolonged rise and fall of the vessel, easily mistaken for a minor change in the sea state. The immense energy of the wave is spread across an incredibly long wavelength, sometimes hundreds of kilometers from crest to crest, making it appear as a subtle, almost invisible undulation. However, as this silent, fast-moving energy wave approaches the shallower waters of a coastline, its character undergoes a dramatic and terrifying transformation. The rising seafloor begins to exert friction on the bottom of the moving water column, causing the tsunami to slow down profoundly. As its speed diminishes, the energy that was once spread across a vast horizontal distance is now compressed into a much shorter wavelength, forcing the water to pile up. The wave's height begins to grow slowly at first, then with increasing rapidity transforming from an imperceptible swell into a towering wall of water. This is when the true devastating power of a tsunami reveals itself. The arrival of a tsunami at a coast can manifest in several terrifying ways. Sometimes the initial sign is a dramatic and sudden recession of the ocean, as if the sea itself is drawing a deep, silent breath, pulling water far out from the shore, exposing vast stretches of seabed reefs and marine life that were once submerged. This unnatural ebb, often accompanied by an eerie silence or a distant rumbling roar, is a profound warning, a precursor to the devastating surge that follows. Then, without warning, the sea returns not as a breaking wave, but as an immense, fast-moving flood, a colossal river of water surging inland, often carrying with it an overwhelming debris field of everything it has already consumed. This isn't merely a wave breaking on the beach, it is an entire colossal volume of ocean water, often many meters high, rushing inland with immense momentum, sweeping away everything in its path. Buildings, trees, vehicles, and people are effortlessly engulfed, crushed, and carried along in the churning, debris-laden torrent. The force is unimaginable, capable of tearing structures from their foundations, carving new channels into the land, and depositing heavy objects far inland. The water can penetrate kilometers inland depending on the topography, receding only after its energy is spent, leaving behind a landscape of utter devastation and a chilling silence broken only by the groans of dying structures and the cries of the injured. The 2004 Indian Ocean tsunami, triggered by a magnitude 9.1 earthquake off Sumatra, and the 2011 Tohoku tsunami in Japan, following a magnitude 9. The earthquake stand as stark, tragic reminders of the ocean floor's capacity to unleash such overwhelming, indifferent destruction. Beyond the sudden, dramatic upheaval of earthquakes, the ocean floor harbors another potent source of danger: submarine landslides. Imagine the colossal slopes of submerged mountains, vast canyons, and continental shelves, all covered with layers of accumulated sediment slowly, patiently deposited over millennia. These underwater slopes, much like their terrestrial counterparts, are susceptible to instability. The weight of the overlying sediment, combined with factors like seismic shaking from earthquakes, the destabilization of gas hydrates, frozen methane trapped in the seabed, or even rapid sedimentation from river deltas, can cause these colossal masses of material to suddenly give way. When a submarine landslide occurs, it is an event of truly immense scale. Billions of tons of sediment, rock, and debris can detach from a slope and cascade down into the abyssal plains, often at surprisingly high speeds, creating what are known as turbidity currents. These are dense, fast-moving flows of sediment-laden water, like underwater avalanches that can travel for hundreds, even thousands of kilometers across the ocean floor, carving out channels and depositing vast fans of material. The energy released by such an event is staggering. The Storegga slide off the coast of Norway, which occurred approximately 8,200 years ago, involved the movement of an estimated 5,000 cubic kilometers of material, a volume equivalent to a block of land, 20 kilometers long, 25 kilometers wide, and 10 kilometers thick. While the direct impact of a deep-sea turbidity current is unlikely to be experienced by humans, these silent, hidden avalanches pose two profound dangers. Firstly, they can severely damage or sever critical underwater infrastructure such as fiber optic communication cables that crisscross the ocean floor, disrupting global communications and economic activities. Imagine the sudden, unexplained silence of a continent losing its digital voice, severed by an unseen force miles beneath the waves. Secondly, and more catastrophically, a large submarine landslide can displace an immense volume of overlying water, just like an earthquake, generating a powerful tsunami. The Storegga slide, for instance, is believed to have generated a mega tsunami that inundated coastlines across the North Atlantic, leaving behind geological evidence of its devastating reach. These events are often silent, unseen, and their consequences can travel across entire oceans, a testament to the hidden, restless nature of the Earth beneath the waves. Finally, we turn our gaze to the fiery heart of the ocean floor, the realm of submarine volcanism and hydrothermal vents. Far from being a static, inert basin, the ocean floor is a dynamic crucible where new crust is constantly being forged. Along the vast, interconnected network of mid-ocean ridges that snake across the globe, tectonic plates are slowly pulling apart. As they separate molten rock or magma from the Earth's mantle, rises to fill the void, erupting onto the seafloor and creating new oceanic crust. These submarine volcanoes are the most common volcanic features on Earth, though most remain hidden from our view. Most submarine eruptions are effusive, meaning they produce slow, gentle flows of lava that cool rapidly in the frigid seawater, forming characteristic pillow-shaped formations. However, some can be explosive, particularly in shallower waters, where the overlying pressure is less intense, allowing superheated water to flash into steam, triggering violent bursts. Imagine the immense heat of molten rock, thousands of degrees Celsius, meeting the near-freezing water of the deep ocean. The immediate effect is a dramatic, localized heating of the surrounding water, potentially scalding any marine life in the immediate vicinity. The eruption also releases vast quantities of gases and chemicals, some of which can be toxic, altering the local water chemistry and creating plumes that can travel for many kilometers. Even more pervasive than direct eruptions are the hydrothermal vents, which we briefly touched upon in our discussion of temperature extremes. These are not always active volcanoes, but rather areas where seawater seeps down into cracks in the oceanic crust, becomes superheated by the underlying magma, and then rises back to the seafloor, carrying with it a rich cocktail of dissolved minerals. These black smokers, or white smokers, spew forth fluids that can reach over 400 degrees Celsius, far hotter than boiling water at the surface, prevented from boiling only by the immense hydrostatic pressure. For any life form or human technology unprepared for such an encounter, these vents represent a localized yet profound danger. The scalding plumes of water are instantly lethal, capable of cooking organisms alive or melting sensitive equipment. The chemical composition of the vent fluids, rich in hydrogen sulfide heavy metals and other compounds, is highly toxic to most forms of life, though it forms the very basis of the unique chemosynthetic ecosystems that thrive around the vents. Imagine a remote-operated vehicle slowly exploring the abyssal plain, inadvertently drifting into a plume of superheated, chemically potent water. Its sensitive sensors and delicate components suddenly overwhelmed by an invisible burning cloud. The Earth's restless floor, therefore, is a realm of profound, indifferent power. From the silent genesis of tsunamis that can sweep away coastal civilizations, to the colossal, unseen submarine landslides that reshape the ocean depths and trigger distant waves of destruction, to the fiery birth of new crust and the scalding chemical breath of hydrothermal vents. The geology beneath the waves is a constant, dynamic force. It is a reminder that even in the deepest, darkest, most seemingly tranquil parts of the ocean, the Earth itself is alive, constantly shifting, breathing, and occasionally unleashing forces that underscore our fundamental fragility in the face of its immense geological might. Let these images of the ocean's deep, restless foundations settle gently within your mind, as we continue our slow journey into the depths of its formidable mysteries. Harmful algal blooms, pathogens and unseen life. As the profound geological forces of the Earth's restless floor begin to recede into the quiet depths of our contemplation, we now shift our focus to an even more pervasive, yet often utterly invisible realm of danger, the microscopic world. Within every drop of seawater, in every swirling current and clinging to every grain of sand, there exists an astonishing unseen universe of life, teeming with organisms so tiny they defy our naked eye. While many of these minute inhabitants are vital architects of the ocean's health, others possess a silent, insidious power, capable of unleashing toxins, disease, and disruption on a scale that can ripple through entire ecosystems and even impact human health, making the ocean a vast living brew of both sustenance and subtle peril. Consider first the phenomenon of harmful algal blooms, or HABs, often more dramatically, though somewhat misleadingly termed red tides. These occurrences are not, as the name might suggest, always red, nor are they always caused by tides. Rather, they are a natural, yet increasingly frequent proliferation of certain types of microscopic algae or phytoplankton that can produce potent toxins under specific environmental conditions, perhaps an abundance of nutrients washed into coastal waters from land, combined with warm temperatures, abundant sunlight, and calm stratified waters. These tiny single-celled organisms can multiply exponentially, transforming vast expanses of ocean water into a dense, soupy broth, often painting the surface with startling hues of green-brown, or indeed vivid crimson. The true danger of these blooms lies not in their visual spectacle, but in the invisible poisons they release. Different species of phytoplankton produce different classes of toxins, each with its own specific, often devastating impact. One of the most notorious groups of these microscopic architects of peril are the dinoflagellates, tiny organisms propelled through the water by two whip-like flagella. Certain species of dinoflagellates are responsible for producing saxitoxins, the compounds behind what is known as paralytic shellfish poisoning, or PSP. These neurotoxins are among the most potent natural poisons known, capable of disrupting nerve function in animals and humans. Imagine a calm coastal bay, seemingly pristine, where shellfish like mussels, clams, and oysters filter vast quantities of water, silently feeding on the abundant phytoplankton. During a PSP bloom, these shellfish, being filter feeders, accumulate the saxitoxins in their tissues without being harmed themselves. They become living reservoirs of invisible poison. For a human who then consumes these contaminated shellfish, the effects can be swift and terrifying. Within minutes to hours, a tingling sensation might begin around the lips and tongue, spreading to the face and neck. This is followed by numbness, a strange creeping paralysis that affects the extremities, making movement difficult. As the toxin progresses, it can lead to muscular weakness, dizziness, and a profound sense of lightheadedness. In severe cases, the paralysis extends to the respiratory muscles, making breathing an agonizing struggle. And without immediate medical intervention, it can lead to respiratory arrest and death. The ocean, in its silent microscopic chemistry, can turn a seemingly innocent meal into a deadly encounter. Another class of dinoflagellate toxins are the brevetoxins, responsible for neurotoxic shellfish poisoning, or NSP. These toxins, produced by species like Karenia brevis, often lead to large-scale fish kills, leaving beaches littered with the bodies of marine life, a visible sign of the invisible poison at work. For humans, NSP can cause a range of gastrointestinal and neurological symptoms, including nausea, vomiting, diarrhea, and tingling sensations, but also a peculiar reversal of hot and cold sensations. Beyond consumption, brevetoxins can also become aerosolized, carried into the air on sea spray, particularly during heavy surf. Imagine walking along a beach, breathing in the fresh sea air, only to find yourself developing respiratory irritation, a persistent cough, and a constricted feeling in your chest, all caused by microscopic toxins carried on the very breath of the ocean. Not all harmful blooms are caused by dinoflagellates. Certain species of diatoms, another group of abundant phytoplankton, can produce domoic acid, a neurotoxin responsible for amnesic shellfish poisoning, or ASP. This toxin accumulates in shellfish and certain fish, such as anchovies and sardines. When consumed by marine mammals like sea lions or birds, it can cause disorientation seizures and even death, leading to tragic strandings and mass mortality events. For humans, domoic acid poisoning begins with gastrointestinal distress, but can quickly escalate to more severe neurological symptoms, including confusion, short-term memory loss, hence amnesic, and in severe cases, seizures and coma. It is a chilling reminder of how a microscopic organism can subtly alter brain function, stealing memories with its invisible touch. Beyond the realm of algal toxins, the ocean is also a vast reservoir of various pathogens, bacteria, viruses, and parasites, many of which pose direct threats to human health. One of the most notorious groups of marine bacteria is the Vibrio genus. These naturally occurring bacteria thrive in warm, brackish, and saline waters, particularly during warmer months. Among them, Vibrio vulnificus has earned a fearsome reputation. It is often referred to as flesh-eating bacteria, though this term, while dramatic, doesn't fully capture its insidious nature. This bacterium typically enters the human body through two primary pathways: consumption of raw or undercooked seafood, especially oysters, or through open wounds exposed to contaminated seawater. For those with compromised immune systems, liver disease, or diabetes, Vibrio vulnificus can be devastating. If ingested, it rapidly invades the bloodstream, causing a severe and often fatal form of sepsis, characterized by fever chills, a precipitous drop in blood pressure, and blistering skin lesions. If it enters through a cut or scrape, the infection can progress with alarming speed, causing severe pain swelling and rapidly spreading tissue necrosis, literally dissolving flesh around the wound. The infection can lead to amputation or death within a matter of days. Imagine a small cut sustained while enjoying a day at the beach, slowly transforming into an agonizing, life-threatening infection, all from an invisible bacterium lurking in the seemingly benign water. Other Vibrio species, such as Vibrio parahemolyticus, are more commonly associated with severe food poisoning from raw or undercooked seafood, causing symptoms like diarrhea, abdominal cramps, nausea, and vomiting. And Vibrio cholerae. The causative agent of cholera, though often associated with freshwater contamination, can also survive in brackish marine environments and be transmitted through contaminated shellfish. These bacteria, unseen and unfelt, are a constant silent presence in the ocean, waiting for an opportunity to invade and sicken. Viruses too find their way into the marine environment, often carried by human sewage. Norovirus, highly contagious agent responsible for widespread outbreaks of gastroenteritis, can contaminate shellfish beds. When these filter-feeding bivalves ingest virus-laden water, they accumulate the pathogens in their digestive systems. Consuming raw or undercooked contaminated shellfish can then lead to a rapid onset of severe vomiting and diarrhea. Similarly, hepatitis A virus, which causes inflammation of the liver, can also be transmitted through the consumption of raw shellfish, harvested from contaminated waters. The ocean in these instances acts as an unwitting intermediary, concentrating human pathogens and returning them to us. Beyond bacteria and viruses, various parasites invisible to the naked eye can also lurk within marine organisms. Anisakis, a genus of parasitic roundworms, is a common inhabitant of marine fish and squid. When humans consume raw or undercooked seafood containing these live larvae, often found in sushi sashimi or ceviche, the worms can attempt to burrow into the lining of the stomach or intestine. This can cause intense abdominal pain, nausea, vomiting, and sometimes severe allergic reactions. The sensation of a living organism attempting to penetrate one's digestive tract is both medically serious and deeply unsettling, a visceral reminder of the hidden life within our food. Other less common parasitic worms like certain cestodes, tapeworms, and trematodes flukes can also be acquired through the consumption of raw or improperly prepared marine products, causing a range of gastrointestinal and systemic illnesses. Finally, we must consider a unique and particularly insidious marine toxin, ciguatera. This poison is not produced directly by fish, but originates from a microscopic dinoflagellate called Gambiodiscus toxicus, which typically grows on macroalgae and coral surfaces in tropical and subtropical waters. Herbivorous fish graze on these algae, ingesting the dinoflagellates and accumulating the ciguatoxins in their flesh. As these herbivorous fish are eaten by larger carnivorous fish, such as barracuda snapper grouper and mahi-mahi, the toxins biomagnify up the food chain, reaching high concentrations in the tissues of these apex predators. The danger of ciguatera is particularly insidious because the toxins are odorless, tasteless, and heat-stable, meaning they cannot be detected by smell or taste, nor are they destroyed by cooking, freezing, or any other preparation method. A perfectly cooked, delicious-looking fish can harbor a deadly secret. For humans who consume contaminated fish, the symptoms of ciguatera poisoning are a bizarre and often long-lasting array of neurological and gastrointestinal effects. Initial symptoms might include nausea, vomiting, and diarrhea, but these are often followed by a perplexing and debilitating suite of neurological disturbances. Victims might experience tingling and numbness in the extremities, excruciating joint and muscle pain, profound fatigue, and perhaps most famously, a disturbing reversal of hot and cold sensations, where cold objects feel burning. Hot and hot objects feel freezing cold. These neurological symptoms can persist for weeks, months, or even years, causing chronic discomfort and disability, and there is no specific antidote. Ciguatera is a silent, enduring curse, a testament to the complex, hidden chemical ecology of the coral reef. From the silent, toxic blooms that paint the surface of the sea, to the insidious bacteria and viruses that lurk within its waters and its inhabitants, and the perplexing, long-lasting effects of ciguatera. The microscopic world of the ocean presents a constant, invisible challenge. These are not the dramatic, visible forces of waves or the crushing embrace of pressure, but rather a quiet, pervasive threat, capable of disrupting life at its most fundamental level, sickening, debilitating, and sometimes ultimately stealing away the very breath of life itself. Let this understanding of the ocean's unseen dangers, its microscopic menace, settle gently within your thoughts as we continue our slow, quiet journey into the depths of its formidable mysteries. Venomous invertebrates and their potent defenses. As our thoughts gently journey from the vast, unseen dangers of microscopic life and the deep, silent rumble of Earth's restless floor, we now turn our attention to another formidable yet often visually captivating category of ocean inhabitants, the venomous invertebrates. These are creatures without backbones, often possessing an ethereal beauty or a deceptive stillness, yet armed with potent chemical defenses, silently waiting in the currents, clinging to the reef or burrowing in the sand. Their sting is often a quiet, almost imperceptible event, yet its consequences can range from excruciating pain to swift, life-threatening paralysis, a testament to the ocean's capacity for elegant, yet profoundly dangerous, biological engineering. First, let us contemplate the Cnidarians, a phylum of marine animals that includes jellyfish, sea anemones, and corals. These creatures share a common defining characteristic: specialized stinging cells called nematocysts. Each nematocyst is a microscopic barbed harpoon, coiled under immense internal pressure, ready to fire with explosive speed upon contact. Imagine a tiny spring-loaded dart, loaded with a potent cocktail of toxins waiting in the millions across the surface of a jellyfish tentacle. When triggered by touch, this microscopic weapon rapidly injects its venom into an unsuspecting victim, a silent, almost instantaneous delivery system of biochemical pain. Among the Cnidarians, the jellyfish stand out as particularly formidable. Their translucent, bell-shaped bodies drift gracefully through the water, their often long, trailing tentacles a mesmerizing yet perilous extension. The most infamous of these is the box jellyfish, scientifically known as Chironex fleckeri. Found predominantly in the warm coastal waters of northern Australia and the Indo-Pacific. Imagine a creature of almost ethereal beauty, its bell, a pale shimmering cube, sometimes no larger than a human fist, yet trailing up to 60 tentacles, each stretching up to 3 meters in length. These tentacles are almost entirely transparent, rendering them virtually invisible. In the water, a silent, unseen snare. The venom of Chironex fleckeri is considered one of the most potent and rapidly acting marine toxins in the world. It is a complex mixture of neurotoxins, cardiotoxins, and dermatonecrotic toxins designed for the swift incapacitation of prey, primarily fish. For a human contact with even a small section of a tentacle can trigger immediate agonizing pain, often described as a searing white-hot burn, as if molten metal has been poured onto the skin. The affected area quickly develops raised reddish-purple welts, sometimes resembling the marks of a whip. However, the true danger lies beyond the skin. The neurotoxins rapidly attack the nervous system, causing muscle spasms, difficulty breathing, and a profound sense of panic. The cardiotoxins directly assault the heart, leading to a precipitous drop in blood pressure, rapid heart rate, and within minutes, potentially cardiac arrest and death. The silent, almost invisible touch of this creature can transform a tranquil swim into a desperate, losing struggle for breath, a testament to the swift, overwhelming power of its biological weapon. Even more insidious, perhaps, is the Irukandji jellyfish. A tiny relative of the box jellyfish, often no larger than a human fingernail, with only 4 delicate tentacles, each perhaps a meter long. Species such as Carukia barnesi are found in similar Indo-Pacific waters. Its diminutive size and almost complete transparency make it virtually impossible to see in the water, a truly invisible menace. The initial sting from an irukandji is often barely noticeable, perhaps a mild prick or an itchy sensation so subtle that victims may not even realize they have been stung. However, within 20 to 45 minutes, the symptoms of irukandji syndrome begin to manifest slowly, insidiously, but with terrifying intensity. Imagine a creeping, profound muscle pain spreading through the back, chest, and abdomen, becoming excruciatingly severe, accompanied by widespread cramping. This is often followed by nausea, vomiting, profuse sweating headache, and a disturbing sensation of impending doom. A profound psychological distress that can be overwhelming. The venom, a potent cocktail of neurotoxins and cardiotoxins, causes a massive release of catecholamines, leading to extremely high blood pressure and a rapid heart rate, sometimes causing pulmonary edema or even cardiac failure. The silent, almost imperceptible touch of this tiny creature can unleash a delayed, agonizing cascade of physiological chaos, turning a seemingly harmless encounter into a prolonged medical emergency, a chilling reminder that in the ocean, even the smallest forms of life can harbor immense hidden power. Another well-known cnidarian, though technically a colony of specialized polyps and medusoids rather than a single organism, is the Portuguese man-o'-war. Physalia physalis. Easily recognizable by its iridescent gas-filled float which sails gracefully on the ocean surface, catching the wind like a tiny jewel-toned balloon. Beneath this captivating float, however, trail incredibly long, delicate tentacles, sometimes extending up to 50 meters in length, a vast, invisible net designed to ensnare prey. These tentacles are densely packed with nematocysts capable of delivering a powerful sting. The venom of the Portuguese man-o'-war, while rarely fatal, can inflict intensely painful whip-like welts on the skin, often accompanied by throbbing pain muscle cramps, and sometimes systemic symptoms such as nausea, vomiting, and fever. The sting can be persistent, with venom continuing to release from detached tentacles even after the creature itself has moved on. Imagine swimming through seemingly clear water, only to suddenly feel a searing, electrifying pain wrapping around a limb, leaving behind a vivid, angry red pattern on your skin. A phantom embrace from a creature you may never even have seen. The ocean's currents can carry these beautiful yet dangerous colonial organisms far from their usual habitats, bringing their potent sting to unexpected shores. Moving beyond the drifting cnidarians, we encounter the coke. One snails. Conus species members of the mollusk phylum, renowned for their exquisitely patterned shells. These seemingly placid, slow-moving inhabitants of tropical coral reefs and sandy bottoms belie an astonishingly sophisticated and deadly predatory strategy. Each cone snail possesses a modified harpoon-like radula tooth connected to a venom gland filled with a complex cocktail of neurotoxins known as conotoxins. When a prey item such as a fish or another mollusk comes within striking distance, the snail extends a proboscis, fires its venomous harpoon, and injects a paralyzing dose. For a human often attracted by the snail's beautiful shell and attempting to pick it up, the sting is delivered through this same harpoon. The sensation is often described as a sharp, intense prick, followed by a burning or numbing pain. However, the true danger lies in the conotoxins, which are incredibly potent and highly specific neurotoxins. Different conotoxins target different ion channels and receptors in the nervous system, leading to a rapid and profound paralysis. Symptoms can include intense local pain, swelling numbness, and tingling. As the venom spreads, it can cause muscle weakness, difficulty speaking, blurred vision, and eventually respiratory paralysis, leading to suffocation. The most dangerous species, like the geography cone, Conus geographus, have venom so potent that they have been responsible for human fatalities. The chilling anecdote often cited is the cigarette time, suggesting that a victim may have just enough time to smoke a cigarette before succumbing to paralysis. The cone snail is a testament to the ocean's ability to imbue even the most unassuming creatures with a silent, deadly elegance. Another exceptionally dangerous mollusk, small in stature but immense in venomous power, is the saunter blue-ringed octopus. Hapalochlana species. These diminutive cephalopods, typically no larger than 10 to 15 centimeters, inhabit shallow reef and tide pool environments across the Indo-Pacific. When undisturbed, they are often camouflaged, blending seamlessly with their surroundings. However, when threatened or agitated, their skin erupts in a mesmerizing display of iridescent blue rings, a vivid, unmistakable warning signal that pulses and flashes with an otherworldly glow. The bite of a blue-ringed octopus is often described as almost painless, sometimes just a small prick so subtle that the victim may not immediately realize they have been bitten. However, the octopus's salivary glands produce a powerful neurotoxin called tetrodotoxin, or TTX, the same compound found in pufferfish. TTX is an incredibly potent blocker of sodium channels in nerve cells, leading to rapid and profound paralysis. Within minutes of a bite, symptoms begin to appear: numbness around the mouth and face, difficulty speaking and swallowing, muscle weakness, and a profound creeping paralysis that quickly affects the entire body. The victim remains fully conscious, aware of their surroundings, but utterly unable to move or even breathe as the diaphragm and respiratory muscles become paralyzed. There is no known antidote for tetrodotoxin, and survival depends entirely on immediate and continuous artificial respiration until the toxin is slowly metabolized by the body, which can take many hours. The blue-ringed octopus is a silent, beautiful assassin, its almost painless bite delivering a rapid, terrifying descent into conscious paralysis, a chilling manifestation of the ocean's silent, potent defenses. Beyond these more famous venomous invertebrates, other creatures also carry their own potent stings. Sea urchins. Members of the echinoderm phylum are often covered in sharp, brittle spines that can cause painful puncture wounds, easily breaking off in the skin and leading to secondary infections. Some species, however, possess venomous spines, and many also have delicate pincer-like structures called pedicellarii, which can contain venom. Stepping on a venomous sea urchin can result in immediate intense pain, redness, swelling, and muscle spasms, and in some cases systemic effects like nausea or weakness. The long-spined sea urchin Diadema setosum is particularly notorious for its excruciatingly painful, brittle spines. Even some starfish, such as the crown of thorns starfish. Acanthaster plantae. A voracious coral predator are armed with venomous spines. Contact with these spines can cause immediate throbbing pain, swelling redness, and nausea, often lasting for many hours. The spines are sharp and can easily puncture skin, delivering their toxins and often leaving fragments embedded in the wound. And then there are the teeth bristleworms, such as the fireworm. Hermodis carunculata, an annelid worm found in tropical and subtropical waters. These segmented worms are covered in bundles of white, calcareous bristles, which when touched detach and embed themselves in the skin. Each bristle is hollow and contains a neurotoxin. The contact immediately produces an intense burning pain, accompanied by redness, swelling numbness, and sometimes a persistent itch. Removing the tiny, irritating bristles can be challenging as they are fragile and often break, leaving fragments in the skin. The silent, stinging power of these venomous invertebrates is a profound testament to the intricate and often dangerous biological diversity of the ocean. These creatures, in their myriad forms and hidden strategies, remind us that the allure of the marine world is often accompanied by an inherent, indifferent peril. Their venoms, evolved over millennia for defense and predation, are complex biochemical marvels capable of inflicting pain, paralysis, and in some cases death through a touch that might be barely felt, or a beauty that is utterly deceptive. Let this understanding of the ocean's stinging silence, its potent, invisible defenses, settle gently within your mind as we prepare to drift deeper into its formidable living mysteries. Dangerous fish of the reef and open sea. As the subtle, insidious threats of microscopic life and the vast geological tremors of the Earth's restless floor begin to recede into the quiet depths of our understanding. We now turn our attention to another category of formidable inhabitants within the ocean's embrace, the fish. These creatures, often camouflaged masters of their environment or possessing an unexpected hidden power, navigate the currents and cling to the reefs armed with specialized defenses that can deliver excruciating pain, paralyzing toxins, or even disorienting electric shocks. Their danger is often silent, a hidden barb or an unseen current, a testament to the ocean's capacity for elegant yet profoundly perilous biological design. Consider first the mink stonefish. Synancea species, a creature so utterly adapted to its environment that it often goes completely unnoticed, a master of disguise lying patiently on the seabed. Found in the shallow tropical waters of the Indo-Pacific among coral rubble rocks and camouflaged against the sandy bottom, the stonefish is perhaps the most venomous fish in the world. Imagine its appearance, a grotesque, lumpy body covered in warty protuberances mottled in shades of brown-grey and green, perfectly mimicking a venom-encrusted rock or a piece of dead coral. Its eyes are small, beady, and almost imperceptible, contributing to its uncanny ability to blend seamlessly into the chaotic textures of the reef floor. Along its dorsal fin, typically numbering 13, are stiff, sharp spines, each one a hypodermic needle connected to a pair of large, muscular venom glands. When disturbed, or more commonly accidentally stepped upon by an unsuspecting wader or swimmer, the stonefish does not flee. Instead, it remains perfectly still, relying on its camouflage. The pressure from a foot compresses the spine sheath, causing the spines to erect and pierce the skin, simultaneously squeezing the venom glands at their base. The venom, a complex cocktail of neurotoxins, cytotoxins, and cardiotoxins, is then rapidly injected deep into the wound, a silent, almost instantaneous delivery of profound pain. The pain from a stonefish sting is almost beyond description, often cited as the most excruciating pain a human can experience. It is immediate, intense, and rapidly escalating, spreading from the site of the puncture wound throughout the entire limb, often described as a searing, throbbing, crushing agony, as if the flesh itself is being consumed by fire. The affected limb typically swells dramatically, turning purplish blue, and can become numb. However, the true danger lies in the systemic effects of the venom. The neurotoxins can cause profound weakness, paralysis, and severe muscle spasms. The cardiotoxins can lead to a precipitous drop in blood pressure, heart rhythm disturbances, and respiratory distress. Without immediate medical attention and the administration of antivenom, a stonefish sting can lead to unconsciousness, shock, and potentially death. The stonefish, with its perfect stillness and hidden barbs, embodies the silent, agonizing peril that can lurk beneath the seemingly benign waters of a tropical reef. Closely related to the stonefish and equally captivating in their appearance are the Shriung lionfish, Nduois, pteroi species. These strikingly beautiful fish, with their flamboyant fan-like pectoral fins and long, flowing dorsal spines, are native to the Indo-Pacific, but have become an invasive species in the Atlantic and Caribbean, posing a significant ecological threat. Their vibrant stripes of red, brown, and white, while a warning to predators, also make them a mesmerizing sight for divers and snorkelers. However, beneath this captivating display lies a formidable defense. Each of their numerous dorsal, anal, and pelvic fins is armed with a sharp, hollow spine, each capable of delivering a potent venom. Unlike the stonefish, lionfish are not ambush predators on the seabed. They are often seen slowly cruising the reef or hovering near coral heads. Their stings are almost always defensive. If cornered, threatened, or carelessly handled, they will orient their venomous spines towards the perceived threat. The venom, while not typically fatal to humans, is a protein-based neurotoxin that causes immediate, intense throbbing pain radiating from the puncture site. The wound swells, becomes red and hot, and can be accompanied by nausea, vomiting, sweating, and difficulty breathing. The pain can persist for many hours, sometimes even days, leaving a lasting memory of the ocean's beautiful yet dangerous warning. Many other members of the scorpionfish family, Scorpaenidae, to which both stonefish and lionfish belong, also possess venomous spines. These include the scorpionfish, themselves often masters of camouflage, blending into rocky bottoms or coral with their mottled cryptic coloration and fleshy appendages. Like the stonefish, they rely on their stillness and disguise. Stepping on or inadvertently touching a scorpionfish can result in a painful sting, though generally less severe than that of a stonefish. The pain is immediate and intense, followed by swelling and redness, and can be accompanied by systemic symptoms such as nausea and weakness. Their danger lies in their hidden nature, their patient waiting blending seamlessly until an unwary touch reveals their sharp, venomous secret. Venturing into the sandy shallows often buried just beneath the surface, we encounter the weaverfish, Trichinus species. These small, elongated fish are common in the temperate and subtropical waters of the eastern Atlantic and Mediterranean, often found in sandy areas where bathers might wade. They typically bury themselves in the sand with only their eyes and their dorsal fin spines protruding, waiting to ambush small prey. It is this hidden posture that makes them a particular hazard to humans. The weaverfish possesses several sharp, venomous spines on its first dorsal fin and on its gill covers. If an unsuspecting person steps on a buried weaverfish or brushes against it, these spines erect and deliver a potent protein-based venom. The pain is instantaneous and excruciating, often described as a burning, tearing sensation radiating from the puncture wounds. The affected area swells dramatically, becomes red and inflamed, and can cause numbness, tingling, and local tissue necrosis. Systemic symptoms, though less common, can include nausea, headache, fever, and in rare cases, cardiac arrhythmias. While rarely fatal, a weaverfish sting can cause intense suffering and secondary infection, turning a pleasant walk along the beach into a profoundly painful ordeal. A silent reminder of the dangers that lie hidden beneath the sand. Shifting our focus from the spiny, venomous fish of the reef and sand, we now consider one of the ocean's most iconic and feared bottom dwellers, the stingray, Dasyatidae family. These flattened, disc-shaped cartilaginous fish, graceful and often placid, glide silently across sandy seabeds, through seagrass beds, and along shallow coastal waters in tropical and temperate regions worldwide. They are generally not aggressive, and their primary defense mechanism is a serrated venomous barb located on their long whip-like tail. A stingray's barb, often 2 or more, is a formidable weapon typically covered in a sheath of skin and equipped with backward-pointing serrations, making it difficult to remove. At the base of the barb are venom glands, which release a protein-based toxin upon penetration. Stingray injuries to humans almost always occur when an unsuspecting person accidentally steps on a camouflaged ray buried in the sand. Startled, the ray reflexively whips its tail upward and forward, driving the barb into the victim's foot or ankle, or occasionally other parts of the body if the ray is handled or provoked. The initial impact of the barb can cause a sharp, intense piercing pain. However, the venom quickly intensifies this, leading to immediate and agonizing pain, often described as a throbbing, burning sensation that can radiate up the limb. The wound itself, often a deep laceration, can bleed profusely and may appear discolored with a bluish or grayish tint due to tissue damage and the venom's effects. Swelling and redness are common, and in severe cases the venom can cause local tissue necrosis, where the flesh around the wound slowly dies, leading to prolonged healing and potential secondary infections. Systemic symptoms, though less frequent, can include nausea, vomiting, weakness, dizziness, muscle cramps, and sometimes even cardiac arrhythmias or respiratory distress. While stingray stings are rarely fatal, the tragic death of crocodile hunter Steve Irwin, who was pierced through the chest by a stingray barb, serves as a stark reminder that if the barb strikes a vital organ, the consequences can be catastrophic. The stingray's defense is a silent, sudden, and profoundly painful warning from the ocean floor. Beyond the barbs and spines, some fish wield a different, equally potent, and entirely invisible weapon: electricity. While the electric eel. Electrophorus electricus is a freshwater inhabitant of South America. Its marine cousins, the Euros, electric rays. Torpediniform's order bring this astonishing biological power into the saltwater realm. These flattened disc-shaped rays, often found buried in sand or mud in shallow coastal waters, and deeper continental shelves worldwide, possess specialized electric organs composed of modified muscle cells called electrocytes. These cells, stacked in columns, can generate a powerful electrical discharge. An electric ray's shock is primarily a defensive mechanism used to deter predators or to stun prey. When disturbed or stepped upon, the ray can deliver a sudden, intense jolt of electricity. The voltage and amperage vary by species, but some larger rays can produce discharges of up to 200 volts and 30 amperes, a significant shock that can be deeply disorienting and painful. Imagine the sudden, invisible force of a powerful electric current coursing through your body, causing involuntary muscle contractions, a profound tingling sensation, and a sudden, overwhelming feeling of being stunned. The immediate effects of an electric ray shock can include intense pain, muscle spasms, and temporary paralysis of the affected limb. More dangerously, the shock can cause disorientation, dizziness, and a loss of balance, which in water can quickly lead to panic and secondary drowning. In rare cases, particularly for individuals with underlying heart conditions, or if exposed to a very powerful shock, cardiac arrhythmias can occur. The electric ray, with its hidden presence and invisible weapon, delivers a silent, stunning blow, a reminder that the ocean holds forces beyond the familiar, capable of disrupting the very electrical rhythms of the human body. Finally, while not venomous or electric, certain fish pose a direct physical threat through their sheer predatory power and formidable dentition. The moray eels. Murayenidae family, for instance, are ubiquitous inhabitants of coral reefs and rocky crevices in tropical and subtropical waters. With their snake-like bodies often beautifully patterned, they lie hidden within their rocky lairs, patiently awaiting prey. While generally shy and non-aggressive towards humans, they are territorial and possess incredibly powerful jaws, armed with rows of sharp, backward-curving teeth, designed to grasp and hold slippery prey. An accidental encounter, perhaps a hand inadvertently placed too close to a moray's hiding spot, or an attempt to feed or provoke, one can result in a severe bite. The moray's bite is not venomous, but the lacerations inflicted by its teeth can be deep and ragged, often leading to significant blood loss and a high risk of infection from the bacteria present in its mouth. Imagine the sudden vice-like grip of powerful jaws and the tearing sensation of numerous sharp teeth, a visceral reminder of the raw, biting power of a hidden predator. Similarly, the Tsunamis barracudas spherina species, a sleek torpedo-shaped predator of tropical and subtropical oceans, is known for its formidable array of dagger-like teeth and its lightning-fast ambush attacks. While barracudas do not typically attack humans unprovoked, they are attracted to shiny objects, sudden movements or splashing which they might mistake for struggling prey. A bite from a large barracuda can inflict deep, severe lacerations capable of tearing flesh and severing tendons. Imagine the sudden, silent flash of a silver body and the instantaneous tearing pain of razor-sharp teeth, a terrifying encounter with a swift, predatory force. From the agonizing, paralyzing sting of the stonefish to the disorienting jolt of the electric ray and the powerful, tearing bite of the moray eel. The fish of the reef and open sea present a diverse array of hidden dangers. These creatures, in their evolutionary ingenuity, remind us that the ocean is a realm where survival often depends on potent defenses delivered with silent precision. Their barbed spines and electric currents are not acts of malice, but simply the raw, indifferent expression of their place in the marine world, a world that demands our respect and quiet contemplation of its formidable living mysteries. Let this understanding of the ocean's hidden dangers, its sharp, silent, and electrifying inhabitants, settle gently within your thoughts as we prepare to drift deeper into its profound, living mysteries. Apex predators and the unpredictable encounters from the hidden barbs and electric currents of the reef's smaller yet potent inhabitants, our journey now expands to encompass the ocean's most formidable living forces, its apex predators. These are the creatures that sit at the very pinnacle of the marine food web, possessing immense power-keen senses and a predatory instinct honed over millions of years of evolution. While encounters with these magnificent hunters are statistically rare, the sheer scale of their capabilities and the unpredictable nature of their realm ensure that an interaction with one of these shadow hunters can be swift, terrifying, and profoundly life-altering, a visceral reminder of our place in the wild, indifferent world beneath the waves. Us. Foremost among these shadow hunters, often stirring a primal fear within the human psyche, are the sharks. These ancient cartilaginous fish, having roamed the oceans for hundreds of millions of years, are perfectly evolved machines of predation. Their sleek, hydrodynamic bodies glide through the water with an effortless grace, propelled by powerful caudal fins, while their sensory organs provide an unparalleled awareness of their surroundings. Imagine the silent, almost imperceptible displacement of water as a large shark approaches its dark, unblinking eyes, scanning its lateral line, sensing the faintest vibration, and its ampullae of Lorenzini detecting the minuscule electrical fields generated by the muscle contractions of potential prey. Among the more than 500 species of sharks, a select few are responsible for the vast majority of documented attacks on humans. The great white shark. Carcharodon carcharias. A creature of immense power and iconic reputation, is perhaps the most famous. Reaching lengths of 6 meters or more and weighing over 2 tons, its formidable presence is undeniable. Great whites are ambush predators, often launching surprise attacks from below, particularly on marine mammals like seals and sea lions, their primary prey. When a human is attacked, scientists believe it is often a case of mistaken identity, where a swimmer or surfer silhouetted against the surface resembles a seal. The initial test bite of a great white delivered with crushing force by jaws lined with rows of razor-sharp, triangular teeth is designed to incapacitate large prey. The sheer trauma from such a bite, massive tissue damage, severe blood loss, and organ injury can be catastrophic, leading to rapid exsanguination or profound shock. The ocean in that moment transforms into a realm of terrifying primal force, a sudden violent eruption of raw power from the depths. Then there is the tiger shark, Galiocerdo cuvier, a truly indiscriminate predator often referred to as the garbage can of the sea due to its remarkably broad diet, which includes everything from fish seals and sea turtles to seabirds and even man-made debris. These large solitary sharks, identifiable by their dark vertical stripes which fade with age, are found in tropical and temperate waters worldwide, often venturing into surprisingly shallow coastal areas, estuaries, and even river mouths. Their wide, powerful jaws and serrated C-shaped teeth are perfectly adapted for shearing through fleshbone and carapace. A tiger shark attack, while less frequent than great white encounters, is often more exploratory and persistent, driven by a less discerning palate, making their bites incredibly damaging and potentially fatal due to extensive tissue loss and internal injury. The silent, almost casual approach of a tiger shark, followed by a sudden, powerful bite, is a chilling reminder of the indiscriminate nature of some of the ocean's most formidable hunters. The bull shark, Carcharhinus lucus, is perhaps the most physiologically unique and ecologically versatile of the big three dangerous sharks. Possessing specialized kidneys that allow it to regulate salt balance, the bull shark has the remarkable ability to tolerate and even thrive in both saltwater and freshwater. This allows them to ascend far up rivers and inhabit brackish estuaries, bringing them into much closer and more frequent contact with human populations than other large sharks. They are found in tropical and subtropical waters globally, often preferring murky, shallow coastal areas. Bull sharks are known for their aggressive territorial nature, particularly in confined spaces. An encounter with a bull shark can be swift and violent, often involving repeated powerful bites driven by territorial defense or a strong predatory instinct. The danger from a bull shark is amplified by its presence in popular swimming areas, rivers and lakes, making it a truly unpredictable shadow hunter in environments we often perceive as safe. While shark attacks are incredibly rare events occurring in only a tiny fraction of human interactions with the ocean, their potential for severe, life-threatening injury is undeniable. The force of their bite, the speed of their movements, and the sheer volume of blood loss they can inflict create a scenario of extreme peril, transforming the inviting blue waters into a place of sudden, terrifying vulnerability. Beyond the sharks, another incredibly powerful and intelligent apex predator commands respect: the orca, or killer whale. Orcanus orca. These magnificent marine mammals, the largest members of the dolphin family, are found in all the world's oceans, from the frigid polar regions to the warm tropics. Orcas are highly social, living in complex family groups called pods, and are renowned for their sophisticated cooperative hunting strategies, targeting a diverse array of prey, including fish seals, sea lions, penguins, and even other whales. Their immense size, reaching up to 9 meters and weighing over 5 tons, combined with their incredible speed and agility, makes them one of the ocean's most efficient predators. Despite their fearsome name and their position at the apex of the food chain, wild orcas have an almost pristine record when it comes to interactions with humans. There are virtually no documented cases of wild orcas intentionally attacking or killing a human. Their intelligence, curiosity, and apparent disinterest in humans as prey are remarkable. However, the sheer power of an orca is undeniable. Imagine the force of a tail slap from a 5-ton animal capable of stunning a seal or breaking the back of a larger marine mammal. The potential for accidental injury, for instance, if a curious or playful orca were to nudge a small boat or a swimmer, is immense, though such incidents are exceedingly rare. The danger, therefore, lies less in their predatory intent and more in their overwhelming physical capability and the inherent unpredictability of any large, powerful wild animal. The few tragic incidents involving orcas have almost exclusively occurred in captivity, where the stress of confinement and unnatural social structures are believed to play a significant role in aggressive behavior. Venturing into the brackish waters of estuaries, mangrove swamps, and coastal rivers, particularly in the Indo-Pacific and northern Australia, we encounter another formidable shadow hunter, the Mditsaf saltwater crocodile. Crocodilus porosus. These colossal reptiles are the largest living crocodilians and the largest reptile in the world, with males routinely exceeding 5 meters in length and weighing over 1,000 kilograms. They are masters of ambush predation, blending seamlessly with the murky water, or dense vegetation along riverbanks, often remaining submerged for extended periods, with only their eyes and nostrils visible perfectly still, patiently waiting for unsuspecting prey to come within striking distance. The danger of a saltwater crocodile lies in its explosive power, its immense bite force, the strongest of any living animal, and its terrifying hunting strategy, which often involves the infamous death roll. When a crocodile attacks, it lunges with astonishing speed, seizing its victim in jaws lined with 80 formidable conical teeth. It then drags its prey into the water, rapidly spinning its body to disorient, drown, and dismember it. For a human, an encounter with a saltwater crocodile is almost always a sudden, violent, and often fatal event. They are highly territorial, especially during breeding season, and will defend their space aggressively. Swimming, wading, or even standing too close to the water's edge in crocodile country is to invite a swift, silent, and overwhelming attack. The danger is not merely hypothetical. These powerful reptiles are responsible for numerous human fatalities each year. A stark reminder that in certain coastal environments, the water itself can harbor a patient, ancient, and utterly lethal predator. While not typically considered apex predators of humans, other marine mammals can pose significant, albeit less lethal threats: seals and sea lions. Charismatic and often playful are nonetheless wild animals with powerful jaws and sharp teeth. If they feel threatened, cornered, or are protecting their young, they can deliver a painful bite. These bites, while not venomous, can cause deep lacerations and are notoriously prone to infection, sometimes leading to a condition known as seal finger, a severe bacterial infection that can cause debilitating swelling and tissue damage, requiring specialized medical treatment. Imagine the sudden, surprising snap of powerful jaws, a quick, sharp pain, and the lingering threat of infection from a seemingly harmless encounter. Even Dio. Dolphins. Often portrayed as benevolent creatures, are powerful wild animals. While instances of aggressive behavior towards humans are rare, especially in the wild habituated dolphins, those accustomed to human interaction can sometimes become overly curious or even pushy, occasionally resulting in accidental injuries from their powerful bodies or playful nudges. Their immense strength and speed mean that even an unintentional collision can cause significant trauma. Beyond the direct, intentional predation or defense, the ocean holds other unexpected physical dangers from large marine life. Marlin and swordfish. Magnificent pelagic predators known for their incredible speed and long-pointed bills are not predators of humans. However, their sheer size power and the sharp weapon they carry can lead to accidental yet severe injuries. Imagine a fisherman grappling with a large marlin, the immense fish thrashing wildly, its bill capable of impaling a person with tremendous force. There have been documented cases of fishermen being severely wounded or even killed by a marlin or swordfish during a struggle, a terrifying consequence of being entangled with such a powerful, struggling creature. The ocean in these moments reveals that even its non-predatory giants can inflict lethal damage through sheer physical might and desperate struggle. Finally, we cast our thoughts into the deepest, darkest realms of the abyss, where the true apex predators remain largely unseen, known only through fleeting glimpses, scientific speculation, and the occasional colossal carcass washed ashore. Here reside the mythical, yet very real, giant squid Architeuthis ducks and the colossal squid, Mesonychoteuthis hamiltoni. These magnificent cephalopods are the largest invertebrates on Earth, inhabiting the crushing pressures and perpetual darkness of the deep ocean. While direct human encounters are virtually non-existent and they are not known to prey on humans, their sheer size and the power they possess stir a profound sense of awe and a lingering question of the unknown. Imagine the immense, intelligent eye of a colossal squid, perhaps 25 centimeters across, gazing into the abyss. Picture its powerful tentacles armed with hundreds of suckers, some of which may be lined with sharp rotating hooks, capable of grappling with and subduing enormous deep-sea sharks and even sperm whales, their only known predators. The thought of encountering such a creature in its natural environment, its colossal bulk emerging from the inky blackness, its powerful arms reaching its parrot-like beak, capable of tearing flesh, is a reminder of the vast, unexplored powers that still lurk in the ocean's profound depths. These are the ultimate shadow hunters, their true capabilities and interactions with the world remaining largely a mystery, a testament to the ocean's enduring secrets. From the silent sensory hunt of the great white shark, to the territorial ambush of the saltwater crocodile and the immense unharnessed power of the orca, the ocean's apex predators are a vivid manifestation of its raw, indifferent strength. Their encounters with humans, though rare, underscore our profound vulnerability in their ancient wild domain. They are not malevolent, but simply powerful beings living out their existence in a world governed by primal laws, a world that demands our utmost respect and quiet contemplation of its formidable living mysteries. Let this understanding of the ocean's shadow hunters, their power and unpredictability, settle gently within your thoughts as we prepare to drift deeper into the complex relationship between humanity and the vast, liquid realm. Debris disorientation and psychological depths. As the echoes of the ocean's living hunters, those formidable apex predators gently fade from our awareness. Our journey now turns inward and outward to contemplate a different spectrum of perils, those born from the indelible imprint of human activity upon the vast liquid realm, and those that arise from the profound psychological depths stirred within us by the ocean's boundless, indifferent void. These dangers are often not of tooth or claw, but of entanglement, disorientation, and the silent, creeping dread that can seize the human spirit when confronted by overwhelming scale and isolation. Consider first the pervasive and often insidious danger posed by the human imprint upon the ocean, the vast, ever-growing accumulation of marine debris. Our modern world, with its relentless consumption and often careless disposal, casts a long shadow across the pristine blue. Among the most lethal forms of this debris is what has come to be known as ghost fishing gear. These are fishing nets, lines, traps, and pots that have been lost, abandoned, or discarded by fishing vessels, yet continue their deadly work, indiscriminately drifting through the currents or settling on the seafloor, silently fishing for years, even decades. Imagine a colossal gill net, perhaps hundreds of meters long, made of strong, durable nylon, drifting unseen in the open ocean. Its fine mesh, designed to ensnare fish, becomes an invisible death trap for a vast array of marine life. A curious sea turtle gliding gracefully through the water might swim into the net, its flippers becoming hopelessly entangled. As it struggles, the mesh tightens, slowly constricting its movements, preventing it from reaching the surface, to breathe, leading to a slow, agonizing suffocation. A magnificent humpback whale migrating across vast ocean basins might inadvertently swim through a discarded fishing line, which then wraps around its fluke or pectoral fin, cutting deeply into its flesh with every powerful stroke, causing debilitating injury, infection, and a slow, painful starvation as it struggles to feed. Seals, sea lions, and even seabirds become ensnared, their desperate struggles only tightening the invisible bonds, leading to exhaustion, injury, and ultimately death. This ghost gear, a silent, perpetual hunter, continues its grim work long after its human masters have forgotten it, a chilling testament to our lasting, unintended impact. For humans, particularly divers and swimmers, ghost fishing gear also presents a direct, physical threat. Imagine descending into the seemingly clear blue depths, exploring a vibrant coral reef, when suddenly, a faint, almost imperceptible line brushes against your leg. As you turn, you see a tangle of old fishing line, almost invisible against the water, snaking through the coral. A moment's carelessness, a misplaced kick, and a limb could become entangled. Panic can set in quickly as the line tightens, restricting movement, perhaps catching on equipment or pulling one deeper into a crevice. The struggle to free oneself can quickly consume precious air, induce hyperventilation, and lead to disorientation in the confined underwater space, transforming a serene dive into a desperate fight for survival, a silent struggle against the forgotten remnants of human industry. Beyond fishing gear, the ocean is increasingly choked by plastic pollution in all its forms. From colossal, derelict fishing vessels and discarded industrial containers that drift for years, becoming navigational hazards for ships and potential sources of further pollution, to the ubiquitous plastic bottles, bags, and packaging that form vast, swirling gyres in the open ocean. The Great Pacific Garbage Patch, for instance, is not a solid island of trash, but a diffuse, immense area where currents concentrate trillions of pieces of plastic debris, from microscopic fragments to refrigerator-sized objects. For marine life, these macroplastics pose direct dangers. Ingestion of plastic bags mistaken for jellyfish, leading to fatal blockages in digestive tracts. Entanglement in plastic strapping or six-pack rings, causing disfigurement, injury, and starvation. For humans particularly, those navigating small boats or sailing vessels, large pieces of floating debris can be a significant hazard, capable of fouling propellers, damaging rudders, or even holing hulls, leaving a vessel adrift and vulnerable in the vast, indifferent ocean. Imagine a quiet night passage, the gentle hum of the engine suddenly interrupted by a jarring thud, followed by the sickening whine of a damaged propeller. The vessel, now at the mercy of the currents, thousands of kilometers from land, all due to a forgotten piece of human detritus. Even more insidious is the accumulation of microplastics, tiny fragments of plastic less than 5 millimeters in size. These microscopic particles, born from the breakdown of larger plastics, or manufactured as microbeads, permeate the entire water column from the surface to the deepest trenches. While we touched upon their chemical threat in an earlier chapter, their physical presence also creates a pervasive, subtle danger. They are ingested by virtually every level of the marine food web, from microscopic plankton to filter-feeding whales, introducing foreign material into delicate biological systems. Scientists are still actively researching the full extent of their physical and chemical impact on marine life, but the sheer ubiquity of these tiny human fingerprints in the vast ocean is a sobering reminder of our profound, lasting mark. As we move from the physical debris to the more abstract dangers, we encounter the profound challenges of disorientation in the ocean's vastness. For humans, our innate sense of direction and balance is heavily reliant on visual cues and a stable reference point. On land, the horizon landmarks and the unchanging pull of gravity provide constant feedback. In the open ocean, particularly far from shore, these familiar anchors vanish. Imagine being adrift in a small boat, or even more terrifyingly simply floating in the water, perhaps after an accident. The horizon, if visible at all, is an unbroken uniform line, offering no distinguishing features above a boundless sky, perhaps clear and blue or thick, with clouds offering no sun or stars for navigation. Below, the water stretches into an opaque, often dark abyss. There are no landmarks, no familiar shapes, no sense of forward or backward, up or down, except for the subtle, confusing sway of the waves. This lack of visual reference can quickly lead to spatial disorientation, a terrifying sensation where the brain struggles to reconcile conflicting sensory information. In the water without a stable platform, the body's proprioceptors, the sensors that tell us where our limbs are in space, become confused. The vestibular system in the inner ear, which governs balance and detects motion, is constantly bombarded by the irregular movements of the waves. Without a clear visual horizon, the brain receives contradictory signals, leading to profound vertigo, nausea, and a crippling inability to determine one's true orientation. This can manifest as a terrifying confusion of up and down, where the surface might feel like the bottom, or the vast sky like a crushing ceiling. Panic can set in quickly, as the desperate need for a stable reference point goes unmet, leading to hyperventilation, increased heart rate, and an overwhelming sense of helplessness. In the utter darkness of night, or amidst the blinding whiteout of a dense fog or a raging storm, this disorientation intensifies, transforming the ocean into a featureless, confusing void, where even the simplest act of swimming in a straight line becomes an impossible task. This physical disorientation quickly bleeds into the psychological depths, giving rise to a profound sense of isolation and loneliness. The sheer, overwhelming scale of the ocean, stretching endlessly in every direction, can make a human feel utterly insignificant, a tiny, fragile speck adrift in an indifferent, boundless universe. The distance from land, from other humans, from all familiar comforts can become an immense, crushing weight upon the spirit. Imagine days stretching into weeks alone on the vast expanse, the sun beating down the waves, relentlessly rocking, the only sounds the creak of a vessel or the ceaseless whisper of the wind. The silence can become oppressive, punctuated only by the mournful cries of seabirds or the mysterious sounds of the deep, amplifying the feeling of profound solitude. This intense isolation can trigger a cascade of psychological challenges. Hope, that most vital of human emotions in a survival situation, can begin to erode slowly, relentlessly, like the sea eroding a shoreline. Despair, a heavy, suffocating blanket, can descend, making every effort seem futile. the mind starved of external stimulation and companionship can begin to play tricks. Hallucinations, both visual and auditory, are common in prolonged periods of isolation and sensory deprivation, blurring the line between reality and illusion, further eroding one's grip on sanity. A distant cloud bank might morph into the outline of a ship, a wave crest into a welcoming shore, only to dissolve back into the indifferent water. Each false hope, a renewed stab of despair. For some, the ocean's vastness can trigger a deep-seated primal fear known as thalassophobia, the intense and irrational fear of the deep, dark ocean. This isn't merely a fear of drowning or sharks, but a profound dread of the unknown that lurks beneath the incomprehensible scale, the crushing pressure, the silent, monstrous potential of the abyss. Imagine gazing into the inky blackness of deep water, knowing that unimaginable creatures and forces exist just beyond the reach of light. Unseen, unheard, yet profoundly present. The thought of being swallowed by this void, of losing oneself entirely in its immensity, can be utterly paralyzing, a profound existential dread that speaks to our deepest fears of insignificance and ultimate oblivion. In extreme situations of survival, the psychological battle can become as challenging, if not more so, than the physical one. The constant struggle against the elements, the gnawing hunger and thirst, the relentless exposure, all combine to wear down the human spirit. Panic attacks, moments of uncontrolled terror, and hyperventilation can quickly drain energy and compromise judgment. In prolonged periods of stress, some individuals may experience a complete mental breakdown, losing touch with reality, succumbing to psychosis, or simply surrendering to the elements in a profound act of resignation. The ocean, with its relentless indifference, patiently waits for the human spirit to falter, to break, to yield to its immense, overwhelming power. Even in the controlled environment of deep-sea exploration, the psychological toll can be immense. Submariners and deep-sea submersible pilots operate in confined spaces surrounded by the crushing embrace of the abyss in perpetual darkness. The constant awareness of the immense external pressure, the knowledge that a tiny flaw could lead to instantaneous implosion, creates an environment of intense, sustained psychological stress. The profound isolation from the surface world, the dependence on the complex machinery, and the stark alien nature of the deep-sea environment demand extraordinary mental resilience. The void's lure in this context is not merely a fear of the unknown, but a constant, tangible presence of ultimate peril, a profound test of human fortitude against the overwhelming forces of nature. From the tangible dangers of ghost fishing gear and plastic pollution, which are the silent, enduring testament to our human imprint, to the disorienting vastness that can steal our sense of direction, and the profound psychological depths that can erode our sanity, the ocean presents a complex array of challenges to the human spirit. It is a realm that demands not only physical resilience, but also immense mental fortitude, a quiet courage in the face of its overwhelming scale and indifferent power. Let this understanding of the human encounter with the ocean's psychological and physical challenges settle gently within your thoughts as we prepare for our final, quiet reflections on this vast, liquid world. Respect, reverence, and the ocean's enduring mystery. As the echoes of the human imprint upon the ocean and the complex psychological depths stirred within us by its vastness begin to softly recede, our long journey through its formidable challenges draws towards a different kind of contemplation. We have traversed realms of crushing pressure and searing cold, of invisible poisons and sudden stinging touches. We have glimpsed the shadow hunters that glide through its currents and the geological forces that reshape its very floor. Yet as these specific dangers settle into the quiet corners of our understanding, a larger, more profound truth emerges: the ocean in all its immense power. And mystery demands not fear, but a deep, abiding respect and a quiet, enduring reverence. The dangers we have explored are not born of malice, but of indifference. The colossal force of a breaking wave is simply the kinetic energy of wind transferred to water building and releasing, with a power that dwarfs human strength. The unyielding squeeze of abyssal pressure is merely the consequence of gravity acting upon an immense dense fluid. The potent toxins of a jellyfish or a cone snail are not weapons wielded with intent, but evolved defenses, intricate biochemical solutions to the challenges of survival in a competitive world. The silent, suffocating zones of oxygen depletion are often the unintended consequences of our own terrestrial actions, magnified and returned by the ocean's vast circulatory system. Each peril, when viewed through the lens of scientific understanding, is a manifestation of the ocean's fundamental ancient laws, a testament to its inherent untamed nature. This understanding, this slow, contemplative unraveling of its processes, naturally cultivates respect. Respect for its scale, which makes our largest endeavors seem small. Respect for its power, which can effortlessly reshape coastlines and humble the mightiest vessels. Respect for its intricate, interconnected life, from the microscopic architects of the food web to the colossal migratory giants that traverse entire basins. To truly respect the ocean is to acknowledge our own fragility within its domain, to recognize that we are visitors in a realm far older and more powerful than ourselves, a realm that operates on geological timescales and with forces that obey only the universal laws of physics and biology. This respect guides our actions, encouraging caution, fostering a desire for knowledge, and inspiring a commitment to tread lightly upon its shores and sail gently upon its surface. Beyond respect, the ocean evokes a profound sense of reverence. It is the cradle of all life on Earth, the very primordial soup from which the first sparks of existence arose billions of years ago. Every breath we take, every drop of rain that falls, every cycle of life on land is inextricably linked to the ocean's vast rhythmic pulse. It regulates our planet's climate, producing more than half of the oxygen we breathe, absorbing vast quantities of carbon dioxide and distributing heat across the globe with its immense currents. It is a living, breathing entity, a planetary lung and heart whose health is intimately intertwined with our own. To gaze upon its shimmering surface, to hear the ceaseless whisper of its waves, to feel the cool spray upon one's face, is to connect with something ancient, vast, and sacred, a force that transcends our immediate understanding and invites a quiet awe. Yet despite all we have learned, despite the remarkable advances in oceanography and marine biology, the ocean retains an enduring, profound mystery. It remains in many ways the last great unexplored frontier on our planet, a vast, enigmatic realm whose secrets continue to elude us. Consider for a moment the immense, unseen expanse of the deep ocean floor. While we possess high-resolution maps of the surfaces of distant planets and moons, less than a quarter of our own ocean floor has been mapped to a resolution that allows us to see its intricate topography in detail. Vast submarine mountain ranges, colossal canyons, and sprawling abyssal plains lie largely unexamined, their geological features and hidden ecosystems waiting to be revealed. We know more about the surface of Mars than we do about the bottom of our own seas. Within these unexplored depths, scientists believe that millions of species still await discovery. Imagine the alien forms, the bizarre adaptations, the unique biochemistries of creatures that thrive in eternal darkness under crushing pressure in near-freezing temperatures, or around scalding hydrothermal vents. Each new submersible dive, each remotely operated vehicle expedition, each trawl of the deep often brings forth new, previously unimagined life forms, challenging our understanding of evolution and the very limits of biological possibility. From bioluminescent fish that paint the darkness with living light, to colossal squid with eyes the size of dinner plates, to microbial communities living kilometers beneath the sea floor. Within the very crust of the Earth, the ocean's biological mystery is boundless. The intricate processes that govern the ocean's vast systems also hold many unrevealed secrets. How do the deep ocean currents moving on timescales of centuries truly influence global climate patterns? What are the full implications of the ocean's absorption of human-generated carbon dioxide, and how will its chemistry continue to shift in the coming millennia? How do the complex interactions between microscopic plankton nutrient cycles and atmospheric conditions orchestrate the planet's vast biogeochemical rhythms? Scientists are tirelessly working to unravel these profound questions, but each answer often reveals new layers of complexity. New questions that beckon us deeper into the unknown. The very origin of life, that most profound of earthly mysteries, is still deeply intertwined with the ocean. Scientists continue to theorize about the conditions of the early Earth's oceans, the chemical reactions that led to the first self-replicating molecules, and the environments perhaps around ancient hydrothermal vents where life first took hold. The ocean in this sense is not just a present mystery, but an ancestral memory, holding the silent, profound story of our beginnings within its ancient waters. So as we bring our thoughts to a gentle rest, let us carry with us this profound understanding that the ocean, in its immense, indifferent power, in its capacity for both breathtaking beauty and formidable danger in its role as the cradle of life and the regulator of our planet, and in its enduring, boundless mystery, silently continues its ancient work. It breathes, it moves, it lives, holding secrets deeper than any trench, and whispering stories older than time itself, a vast liquid presence that will continue to shape our world and stir our imaginations for all the ages to come. And so as we drift away from the vast, profound depths of the ocean, its immense power and enduring mystery allow the images and thoughts to gently dissolve into the quiet currents of your mind. Just as the sea holds countless secrets beneath its surface, so too does the realm of sleep invite us into our own personal, uncharted waters, where the subconscious tides carry us to new, unexplored shores of understanding. Let the profound scale of the ocean, its ancient rhythms and silent wisdom, now cradle your awareness. May the deep, tranquil currents of slumber carry you gently into a restorative, peaceful night. Sleep well. Goodbye, and see you again.